What do we learn from this sketch of the mock Einstein episode? We learn, first, that one cannot trust received opinions, or received versions of great turning points of science or great debates, even if they should happen to be supported by outstanding scholars in the relevant fields. We learn, secondly, that the faults of the received opinions can often be found without detailed archival studies. A careful reading of a few well-known books suffices. Such reading makes us realize, thirdly, that the received versions most of the time are not only incorrect, but much simpler, and much more simple-minded, than the events they describe. Thus we are led to suspect, fourthly, that many so-called great issues, such as the issue between realism and positivism that is usually connected with the mock Einstein conundrum, are sham battles caused by misunderstandings and oversights, and that, taken by themselves and without a historical analysis, of the simple kind mentioned under point 2, they teach us absolutely nothing about science and knowledge in general. From this we learn, fifth, that philosophical systems claiming to have solved such issues are indistinguishable from the productions of con artists except for the fact that con artists know what they are doing while the philosophers do not. And all the philosophical battles that arise when different systems, trying to give different accounts of the same great issue or of the same great step forward or of the same revolution, confront each other with reasons and counter-reasons are ever so much moonshine. The moonshine, of course, and this is the sixth point, is a boon to all those who, lacking the talent to understand and influence a complex historical process, can now be simple-minded and still remain philosophers and can even claim to be more rational than those who are dissatisfied with their naive models. This encourages us, seventh, occasionally to go a little further, to take a critical look at the events allegedly constituting the issues and to rescue, happy face, the participants from the fairy tales that are being told about them. Such an activity is very interesting in itself, for it creates great and often quite unsuspected surprises. It is necessary, if our history and our philosophy are to be more than daydreams posing as the outlines of a real world. Afterward, 1988. Garion Walters, in a series of articles and in a book has tried to show that Mach's foreword to his Physicalische Optik, which contains critical remarks on the theory of relativity, was a fake inserted by Ernst Mach's son Ludwig. Walters' arguments, though indirect, are rather strong and constitute a valuable contribution to Mach's scholarship. The same cannot be said of some of the motives for their acceptance. Many people seem to assume that a person who rejects a theory that is now regarded as gospel by almost everybody in the business has committed a serious mistake. If Mach rejected relativity, then his philosophy must have been lousy indeed. This is sheer dogmatism. General acceptance does not decide a case, arguments do. And I can well imagine that Mach, who tried to find a unified account for physical, physiological, and psychological processes, might have objected to a theory of space-time which not only perpetuated the old dichotomy between physical and psychological space and time but which, in Planck's version, even reinforced it. Relativity was a problem for Mach not because it went beyond sensations and therefore too far, but because it did not go far enough. Some observations on Aristotle's theory of mathematics and of the continuum. 1 in Book 2/2 of his Physics and in Book 13/3 of his Metaphysics, Aristotle explains the nature of mathematical objects. The explanation is fairly simple, but long and elaborate discussions are added to combat alternative views and to eliminate mistakes. I will not go into these discussions, nor will I mention and comment upon the modem debates about their correct interpretation. I will merely present Aristotle's statements, add clarifying remarks, examine consequences in physics, compare them with objections by later authors, and show how they are related to modem problems. In quoting Aristotle I will omit special reference to the physics and to the metaphysics. Here the page numbers speak for themselves. Simple numbers in parentheses such as 14, refer to the sections of the present paper. 2 physical bodies, says Aristotle, have surfaces, volumes, lines, and points. Surfaces, volumes, hnes, and points become the subject matter of mathematics by being separated from bodies, 193b 34. We also read, 1964 28 ff, that physics deals with things that have principles of movement in themselves. Mathematics is theoretical and is a science that deals with things that last, but are not separate. They cannot in any way exist separately, but they cannot exist in sensible objects either. 1077 BL5FF, CF 1085B 35FF. The contradiction is resolved by realizing that things are said to be in many different ways, cf. Met in /2 and numerous other passages. Mathematical objects have separate existence in some of these senses but not in others. Assume that to exist means to be an individual entity that does not depend on other objects and is as real as, or perhaps even more real than 1028b18, physical bodies. If mathematical objects exist in this sense, they cannot be in physical objects, for then we would have two objects in one place, 1076 a 40 ff, cf.998 al 3f. Nor can they be physical objects. Sensible lines are not lines like those the geometer describes. There is nothing perceptible that is straight or curved in the strict geometrical sense. The circle touches the ruler not at a point but after the manner of Protagoras, 998 alf. Neither can we assume that physical objects are combinations of mathematical objects. A combination of static and unperceived objects only yields further static and unperceived objects, 1077 a 34 ff, and joining physical material, bronze, for example, and mathematical shape, an individual sphere, for example, both conceived as complete and self-sufficient individuals, yields a pair of complete and self-sufficient individuals, bronze, sphere, not a single individual having sphericity as a dependent property, 1033b20 ff. Aristotle gives further arguments, not all of them admirable, to show that mathematical entities, interpreted as complete and independent individuals, or as substances, in Aristotle's terminology, are neither in physical objects nor outside of them and separate from them. 3. Although it is not possible to have self-sufficient objects, either in physical bodies or apart from them, that lack important properties of physical bodies, it is possible to have incomplete descriptions of such bodies. For example, there are many statements about objects considered merely insofar as they can be in motion which say nothing about their essential and their accidental properties without it necessarily following that there is motion apart from sensible things or that there is a distinct moving entity in them, 1077 a 34 ff. Similarly, there are properties and domains of knowledge that treat changing objects not insofar as they are moving but insofar as they are bodies or only insofar as they are planes and lines and are divisible, or as indivisibles having position, or as indivisibles only, 1077b23 ff. The same principle applies to harmonics and optics, for neither of these sciences studies objects 221 as sight or as sound but as lines and as numbers, but the latter are attributes belonging to the former. And the same is true of mechanics, 1078 a 14 ff. No error arises from this any more than when one draws a line on the ground and calls it a foot long when it is not, for the error is not included in the premises, 1078 a 18 f. Cf. Berkeley's very similar account in the introduction to his Principles of Human Knowledge, 1710. Bearing this in mind, we can say not only without qualification that what is separable exists but also that what is inseparable exists and is separable by description. For example, the objects of geometry exist, they are sensible objects but only accidentally so, for the geometer does not treat them as sensible objects, 1078 alf. For not all incomplete descriptions of bodies disregard motion and perceptibility. Straight and plain do, torn and polished do not. The last two descriptions contain an implicit reference to changeable physical material. Aristotle's favorite example is simos, meaning snub-nosed, as opposed to concave. The definition of simos contains the matter of the object, for snubness is only found in noses, whereas the definition of concave does not. 1064 a 23 ff. As a result, Straight and plain can be separated in the sense just explained, while torn and polished cannot. Aristotle criticized Plato for separating things such as flesh, bone, and man that belong to the latter category, 194 6 ff, cf 1064 27 ff, and for trying to define lines which are separable from the long and short which are not, planes from the broad and narrow and solids from the deep and the shallow, 1085 9 ff. 5. If a feature or a property or an entity is separable in the sense explained, then we can either treat it as separated, i.e., we can discuss it without paying attention to other features that are also present, or we can give a more complete description. However, we cannot do both at the same time, i.e., we cannot mark or subdivide a physical object by a mathematical point or by a mathematical plane. It is customary in physical calculations to imagine a physical object O cut by a mathematical plane P or to consider a volume V in it, Figure 1. According to Aristotle, this is nonsense. Mathematical planes cannot subdivide physical objects, only physical surfaces can, and those have physical properties not present in the undivided physical body. If P is to divide O, then P must be identified by as a surface, there must be 222. A narrow slit at P, whenever bodies are joined or divided, their boundaries instantaneously become one at one time, namely, when they touch, and two at another, when they are divided. Thus when the bodies are combined the surface does not exist, but has perished, 1002 BIFF. One should compare this account with what the quantum theory says about location and division. 6. These considerations play an important role in Aristotle's theory of place. According to Aristotle, the place of an object is the inner limiting surface of the body that contains the object, 212-7, this inner limit being a real physical subdivision. Hence, if a thing is not separated from its embracing environment but continuous with it, then it has no place in it, but it has a place as part of the whole, 211-29 ff. For example, a bottle partly filled with water and floating in a lake has a place in the lake. The surface consists of the surface where the outside water meets the bottle, added to the surface where the outside air meets the bottle, Figure 2. The water inside the bottle also has a place, viz., the inner surface of the glass where it touches the inside water plus the surface of the inside air that touches the water. Both places are physically identifiable surfaces. However, a drop of water inside the bottle is part of that water, it has no place in that water, it has only, as part of that water, a place inside the bottle. We may say that the droplet potentially has a place inside the water of the bottle and that this potential place can be actualized when the droplet is physically separated from the rest of that water, example when it freezes, 212b3ff. The argument of 3 also shows that place cannot be an inner extension diastema, of a body that stays behind when the body has departed, as place is supposed to stay behind 208 BLFF, for, if there were such an entity, there would be infinitely many places in the same thing, 211b21. This argument, says H. Wagner, Aristoteles Physik für Lesen, Darmstadt 1974, pages 544 and dot. Is one of the great cruces the Aristotelian physics has offered to its interpreters since antiquity. But the situation is rather simple, almost trivial. In the argument, the diastema of a particular body is viewed physically, not mathematically. Place, after all, exerts a physical influence 208 BLL, and it is supposed to be identical with place. Viewing the diastema physically implies that a real physical object is associated with it. Identifying the diastema with place means demanding that this object behave like a place, i.e., that it stay behind when the body whose place it is supposed to be moves on, 208 BIFF. Staying behind the diastema does not turn into a mathematical entity, nor does it change from a particular feature of a particular body into something that is shared by all bodies. Every physical object has its own individual place and therefore its own individual diastema. Hence, every place, having been occupied and left by many different objects, contains many different diastemata, and, As every place is occupied by a body, there is no vacuum, and every diastema is a place, every body will contain an infinity of places. 7 similar remarks apply to the idea that the void might be an independently existing entity, similar to a diastema, 216-23 ff. Local movement consists in one body replacing other bodies. The void was introduced not in order to be replaced by a body. 224. But to receive it, 213b5f. It can, therefore, receive a wooden cube. In this case, there would be two things in the same place, which is impossible, 216b1f. It is interesting to see that Georg Experimenta Nova 1672, Book 2, Chapter 3, reintroduces the diastema as representing the vacuum without mentioning Aristotle's arguments to the contrary but with heavy sarcasm concerning Aristotle's philosophy. 8. Aristotle's account also defuses one of Galileo's arguments against the assumption that heavy bodies fall faster than light bodies. According to the argument, a heavy body can be imagined as consisting of two bodies of different size, one small and therefore light, the other large and therefore heavier. The light part, falling more slowly, will retard the heavier part, which means that the total body will fall more slowly than part of it, contrary to the assumption. But Aristotle does not permit us to consider the separate action of part of a whole unless the part is physically separate from the whole. But then the argument no longer works. 9. Aristotle's view of mathematics has especially interesting applications in the domain of motion. In 5 we saw that, in order to make physical sense, statements about parts and subdivisions must be about physically identifiable separations. A continuous body has no actual parts unless it is cut and its continuity interrupted thereby. To motion, this means that part of a continuous motion can be separated from another part of the same motion only by a real modification, this time of the motion, i.e., the motion must either slow down or come to a temporary halt, it must stop and begin to move again, 262-24f. This is how Aristotle solves one of Zeno's paradoxes. Zeno had pointed out, 263-4ff, that a movement over a certain distance must first cover half the distance, then half of the half and so on, which means that the motion never gets completed. According to Aristotle, one subdivides the motion either by using mathematical points, then no subdivision has occurred, or by using physical, actual 263b6ff, points, then the subdivision changes the motion, turns it into an interrupted motion, 263-30f, which is indeed never completed. 10. Few people are satisfied with this solution. The reason is that the idea of motion usually connected with the paradox differs from the idea Aristotle uses for solving the paradox. Aristotle, the critics feel, does not meet the paradox head-on, he evades it. And he evades it in a particularly simple-minded fashion, introducing acts of subdivision when the problem is the nature of a motion that proceeds without outside interference. The assumption behind the feeling is that the idea of such a motion is without fault, that the paradox arises from a mistaken use of it, and that the task is to correct this mistake and not to start talking about entirely different processes. If this assumption is incorrect, i.e., if the view of motion involved is inadequate and perhaps even incoherent, then its replacement is not an evasive move but a required one. Zeno's argument will then cease to be a mere paradox and will become a further contribution to its downfall. The main question is, what is the view of motion that those who speak of evasion have in mind, and how can it be defended? Briefly, the view can be stated as follows: for every point A of the line to be transversed, the event passing point A is part of the motion whether we now interfere with it or leave it alone. Motions consist of individual punctiform events of this type, and lines consist of individual points. This is an interesting cosmological hypothesis, but is it acceptable? Aristotle says no, and his main reason, which will be discussed in greater detail in 19 below, is very simple. A continuous entity such as a line or a continuous motion is characterized by the fact that its parts are connected or hang together in a special way. Indivisible entities such as points or passings of points cannot be connected in any way whatsoever, hence, lines cannot consist of points and continuous motions cannot consist of passings of points. Similar though more complex arguments are provided by the quantum theory that states that we can have pure motion, well-defined momentum, but without any passing of points or a precise passing of points, but then we have no longer any coherent motion. The assumption is, therefore, incorrect, the view of motion implied impossible, and its removal a necessity, not an evasion. 2. If motion can only be subdivided by modifying it, then any clearly marked subdivision must be accompanied by a temporary change of motion. For example, the stone thrown upward must come to a halt at the highest point of its trajectory, 262b25ff, 263a4f. G. A. Leo, quoted from Drake Drabkin, On Motion and Mechanics, Madison 1960, p. 96, criticized the result by criticizing what Aristotle says when introducing it. There is a temporary halt, says Aristotle, for one point must be reckoned as 226. 2. Being the finishing point of one half of the motion and the starting point of the other, 262b23ff. G. A. Leo objects that, though the turning point may be described in two different ways, as the starting point of one segment and as the finishing point of another, it still is only one point that corresponds to one instant, the instant of reversal. But quite apart from the fact that Aristotle demands an interval, the moving object cannot have arrived at a certain point and departed from it simultaneously, for in that case it would simultaneously be there and not there at the same moment, so there are 2 points of time concerned with a period of time between them. 262b28ff. An interval is demanded also by his general account of the difference between mathematical and physical entities, cf. the quotation at the end of 5. Galileo also uses an example to ridicule Aristotle's account: a line A moves towards 6, with the movement gradually becoming slower. A body C situated on the line moves toward A, with the movement gradually becoming faster, figure 3. Now it is clear that in the beginning C will move in the same direction as the line. And yet since the motion of C is faster, at some moment C will actually move towards the left and W will thus make a change from rightward to leftward motion over the same line. And yet it will not be at rest for any interval of time at the point where the change occurs. And the reason for this is that it cannot be at rest unless the line moves to the right at the same speed as body C moves to the left. But it will never happen that this equality will continue over any interval of time, since the speed of one motion is continually diminished and the other continually increased. This remark criticizes an argument: motions can be subdivided only by introducing physical changes into them, leading to an assertion, temporary halt at points of reversal, by presenting a case that fits the argument, for it is clear that, if the argument is correct, i.e., if motions can be marked, subdivided, only by introducing physical changes such as halts, then the reversal of C will imply a temporary halt of C and, thereby, temporary halts of the two processes of acceleration that create it. 12 different physical entities, and different mathematical entities, may by separation yield the same mathematical entities, example lines and areas, but this does not mean that they can be compared. Thus, curved angles and straight angles can be mapped, figure 4, onto the linear continuum, or, using Aristotelian terminology, a linear continuum can be separated from both of them, but there is no way of saying that a given curved angle is smaller, equal to, or larger than a straight angle. There is no way of inserting a straight angle into a curved angle. Euclid, Elements 3, 16. Similarly, the area of a circle cannot be equal to, smaller than, or larger than the area of a polygon. Bryson's attempt to measure the area of a circle by the area of a polygon: the circle is smaller than any circumscribed polygon and larger than any inscribed polygon. Things smaller or larger than the same are equal to each other, hence, there is a polygon equal in area to the circle, was criticized by Aristotle for precisely this reason. The equal is what is neither great nor small but could be great or small because of its nature, 1056 at 23 ff. According to Aristotle, Bryson uses a common middle term, anal. Post. 75b42f, area, referring to an entity that has been separated both from the circle and from the polygon but without inquiring whether before the separation this entity occurred together with further properties, different in both cases and preventing a comparison, he does not deal with the subject matter concerned. Sophomore Ref 171bl7f, viz., the area of a circle. The geometer, says Aristotle, need not even consider Antiphon's exhaustion of the circle by polygons. The procedure is not just mistaken, it misses its subject matter. 185 al 6f. 13 considerations such as these may explain why Aristotle refused to measure qualitative change by length and why he thought that near and circular motions were incomparable. 227b15ff, 248 alaf. They also explain why the Euclidean definition of mathematical proportions, elements v, def3, is explicitly restricted to homogeneous quantities and why Greek mathematicians and later mathematicians up to and including Galileo never introduced mixed quantities such as velocity defined as a quotient of spatial and temporal magnitudes. But the fact that certain entities such as areas can be separated both from circles and from polygons indicates that they share some properties and that general statements can be made about them. According to Aristotle, such general statements play an important role in mathematics. There are certain general mathematical statements which are not restricted to special substances, 1077 and 9ff. For example, the exchangeability of the inner terms of a proportion was in earlier times proved separately for numbers, lengths, bodies, and time, while this can be shown for all by a single proof. But for lack of a uni-bed notation and because numbers, lengths, times and bodies looked so different, each of them was grasped separately. Now the proof is general, for what it asserts is true not only for lengths as such or numbers as such but for what is assumed to hold for the whole. AN Prince 74 al 7ff. Similarly, some principles are valid for various sciences. An example is the principle that equals taken from equals give equals, AN Post 76 a 38ff. But the generality cannot be taken for granted and must be ascertained by special arguments. 14 Aristotle offers such arguments for linear extension, time, and motion. Linear extension, time, and motion differ in many respects. They are not homogeneous in the sense of Euclid v. def3, c12. Yet, they have common properties. Aristotle's theory of continuous linear manifolds describes the properties and draws consequences from them. The remainder of the present paper will be devoted to this theory. The existence of common properties for length, time, and movements is already hinted at by common sense. For example, we say that the road is long when the journey is long and that the journey is long when the road is long. The time, too, is called long if the movement and the movement if the time, 220b29ff. We also notice that the commonsensical distinction between what is in front and what is behind is a distinction that applies to place and, hence, to extension, and that it must also be true of movement, for the two extension and movement correspond to each other. But if so, then also for time before and after, for time and movement always correspond to each other. 219 al 5ff, cf 218b21ff. For Aristotle such analogies are reasonable, 220b24, because extension, time, and movement are all continuous and divisible quantities, 24ff, and are related to each other in such a way that whatever is true of one is true of all, 231bl9ff. Now continuous, divisible, and quantity as defined in geometry are technical terms. Moreover, Aristotle has a rather elaborate theory of continuity. It needs, therefore, special arguments to show that the analogies noticed apply to these technical entities as well, and to determine their limitations. 15 By continuous, defines Aristotle, I mean what is divisible into further divisibles without end, 232b25f, the parts being distinguishable from each other by their place, 231b6f. The second part of this definition, and of the arguments that surround it, restrict the discussion to linear extended continua. Other types of continua such as sounds, 226b29, and further properties not related to place, 3 if, are mentioned but not examined. The definition makes assumptions that may seem obvious to modem readers but that require analysis and were not regarded as trivial in Aristotle's own time. The assumptions are, 1. That there are entities that can be divided at any point and in any interval, however small, 2. That the division does not change the extension of the entities and of any one of their parts, and, 3. That the division does not obliterate any interval, however small. Assumption 1 was opposed by mathematicians, Democritus perhaps included, who assumed minimal lengths or indivisible lines. Assumptions 2 and 3 were criticized by Zeno, who denied the existence of things without thickness, mass, and extension. For that which neither when added makes a thing greater nor, when subtracted, makes it less, he asserts to have no being, evidently assuming that whatever has being is a spatial magnitude, 1001 b6 ff. During the 18th and 19th centuries, Assumption 1 was often supported by reference to something called intuition, Anschauung, and the idea of a continuum as a kind of gooey substance out of which we pick a point here and a point there. H. Whale, Über die neue Grundlagenkreis der Mathematik, was referred to this dubious source. Are there better ways of supporting the idea of a linear continuum and of the assumptions involved? 230. 16. One of the arguments against indivisible lines was they provide a common measure for all lengths so that there would not be any incommensurable magnitudes. Another argument was that the laws of geometry would cease to be valid below a certain length. The line bisecting the angle of an isosceles triangle consisting of minimal sides could no longer be said to hit the middle of the opposing side, on indivisible lines, 970 f. To see these criticisms in the proper light, let us consider an important consequence of incommensurability. One way of finding the greatest common measure for two magnitudes was the method of antoneresis: subtract the smaller from the larger, the difference from the smaller, and so on until you obtain 0, figure 5. The last number in the sequence before you reach 0 is the sought-after measure. The procedure was used by mathematicians, but it was also used by carpenters, architects, and geographers for finding the greatest common measure for physical lengths. For incommensurable lines such as the side and the diagonal of a square, antoneresis has no end. According to some authors, such as Kurt von Fritz, incommensurability was discovered by discovering this property. Incommensurability could be discovered in this manner only by people who took it for granted that geometrical relations are independent of the size of the figures described. But this was a matter that the Pythagoreans did not take for granted. They assumed that the void was structured by indivisible units kept 231 separated by the void. On such an account geometrical relations cease to be valid below a certain miminal length, and the discovery cannot be made. This is a strong argument for giving precedence to the proof reproduced in Euclid's Elements Book X. Assume that the relation between the diagonal d of a square and its side s can be expressed with the help of integers d and s. Then equals 2s caret. Reduced to the lowest form, this means that d caret is even, therefore, d is even and s if odd. Now, since d is even, d equals 2 and 2f equals 5 caret, or, reduced to lowest form, s is even. Hence, 5 is both even and odd. According to Eudemus, report in Pappus, Commentary of Euclid, I.44, the Pythagoreans founded not only arithmetic but also geometrical algebra. It is often assumed that they did so in order to treat incommensurables in a rigorous manner. Numbers cannot do the job, so lines are introduced in their place. But, if that was the motivation, then the conception of a line must have undergone a drastic change, from a collection of individual units separated by a void to a genuine continuum whose parts, however small, have exactly the same structure as the whole. Was this transition the result of a discovery made inside the Pythagorean school, or was it due to outside ideas? There did exist an outside view that contained all the elements of a continuum, Parmenides' view of the one. According to Parmenides, Dielskrantz, Fragment der Vorsätzlichkeit, Berlin, many editions, B8, 29 ff, being is in its totality homogeneous, homoion, it is nowhere more or less and it is connected as a whole. The word Parmenides uses for connected, zinches, is the technical term used by Aristotle in his own account. I suggest that the idea of a line as a continuous entity with the same properties everywhere, in the large as well as in the small, comes from Parmenides' account of the one. But a line can be divided and the one cannot. On the other hand, if an entity having the properties of the one can be divided, note that the division must come from the outside, it is not part of the line itself, then, if it can be divided at one place, it can be divided everywhere, and in exactly the same manner, because of homogeneity. Considerations such as these may give us some historical understanding of Assumption 1 of 15. The assumption was not trivial, and it was not based on intuition. 17 Assumptions 2 and 3 can be supported by arguments showing that the entities used for subdividing a linear continuum are unextended and indivisible. Aristotle offers such arguments. 232. For the case of the now, i.e., the instant that divides time into past and future. And, since he shows that time, extension, and locomotion are three different but structurally similar linear continua, this argument applies to all subdivisions. To be shown. The primary now is indivisible, a moment or interval for an event or a change is primary if it does not contain any interval in which the event or the change does not occur. 235b34 ff. Thus, the statement that Caesar was assassinated in the year 44 BC does not give the primary or immediate time for the event. Argument, 233b33 ff. The now is a limit of the past, for no part of the future lies this side of it. It is also a limit for the future, for no part of the past lies beyond it. Both limits must coincide. If they were different, then they would either include time or there would be no time between them. If there is no time between them, then they succeed each other, but they cannot succeed each other for succession assumes separation. This point will be argued below in 21. If there is time between them, then it can be divided, part of it will be in the future, part of it will be in the past. We are not dealing with the primary now. Result, the primary now cannot be divided, and, being a limit of an extended continuum, is also without extension. Leibniz, in a short essay on motion and continuity, Philosophische Schriften, ed. C. I. Gerhard, Berlin 1885-1890, Volume 4, pages 228 f, especially 4, that contains a systematic presentation of part of Aristotle's theory of motion and continuity, has improved this argument and extended it to all limits, divisions, and terminations. Take a line of and consider its beginning, A, figure 6. Divide the line in the middle, at CCB does not contain A of is, therefore, not the primary end, and CB can be omitted. Divide AC at DCD does not contain the end, hence, AC is not the primary end and DC can be omitted, and so on as long as we are dealing with any interval, however small. Conclusion, the primary end of the line of, or the primary division of a line that extends beyond A to the left, is indivisible, cf also UQD, elements I, DEFS 1 and 3. This establishes assumptions 2 and 3 of 15. 18 Another argument consists in pointing out that divisions, ends, and sections do not belong to the same category as do lines. The now is not time but an accidental property of it, 220-21 f, and lines, or the things derived from them such as points are not independently existing substances but sections and EV. 233. Figure 6. Zions. And limits of something else. And they inhere in something else, 1060b Lof, however, they adhere not as parts, 220-16, that could exist independently, 1060b 17, and could therefore obliterate a corresponding interval of a line when dividing it. Zeno's objection, 1001b 5f, cf 14, is met by noting that adding limits and slash or subdivisions increases number of subdivisions, not size. For example, a thrice divided line is not longer than a twice divided line, but it has different properties. 19. I am now ready to present Aristotle's theory of continuity and motion. I will not explore all the ramifications of the theory, nor will I try to remove all the lacunae and ambiguities, there are very few of them. I will certainly not try to present the theory in a form that satisfies modern standards of mathematical rigor. To start with, there are no generally accepted versions of such standards. Creative mathematicians, physicists, and systematizers have always gone different ways. Second, standards of rigor, when firmly imposed, often inhibit discoveries or make the formulation of the discoveries impossible, cf. the views of Lakatos and, to a lesser extent, of Polye. Third, dressing up Aristotle in modem garb would conceal his achievements. Aristotle was the foremost mathematical philosopher of his time, and he was well acquainted both with the technical problems and with the most precise ways of formulating them. Trying to present him in modem terms would disrupt this historical connection. Fourth, those modem thinkers who either criticize Aristotle, Galileo, for example, cf 25, or who repeat him, H. Whale, cf 21, use language very similar to his own. 20. The theory is based on a series of definitions. 226b18f things are together when they have the same primary place, for primary, c17, for place, cf6, they are upper when this is not the case. Things touch when their extremes are together. A is contiguous with B to A touches B. A is continuous with B if A is 234. Contiguous with B and the ends of A and B are one or, as the word implies, are contained in each other, 227a15f. Between is defined by reference to change, as are other notions in Aristotle's physics, cf 262f. Every change involves opposites, cf 190b34ff, that are contraries, 227a7ff, and as such extremes, 226b26. Every stage of a continuous motion with given extremes that has passed one extreme and not yet reached the other is between these extremes. The extremes need not be locations, they can be sounds, colors, and other properties that admit of a linear arrangement. A is the successor of B if A and B are of the same kind and if there is nothing of this kind between A and B. A and B are part of a linear continuum if there are continuous C, 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 C. C between A and B such that A is continuous with C, C is continuous with C. And Cn is continuous with B. From now on, the discussion will be restricted to linear continuous manifolds in this sense. Aristotle defines between after touching, thus assuming continuity before it has been defined. I have changed the sequence, using the definition of betweenness to restrict the earlier definitions to series of events. The definitions make it clear that continuity belongs to things which become one by touching, 227a14ff. They thereby solve the problem as to what it is that makes a continuum such as an individual line a single individual thing, cf 1077a21ff. In the physical world, things become one by virtue of a functional unit or a soul, otherwise, they are aggregates. Linear continua hold together because their parts are connected in the manner just described. 2.1. The definitions imply. Proposition 1, linear continuous manifolds do not consist of, indivisibles. Proof, indivisibles have no parts, therefore they have no ends and cannot hang together in the way described. For example, lines do not actually contain points though, being divisible anywhere, they contain points potentially. And, since points mark intervals, we must also say that the parts of a line, such as its right half or its second fifth from the left, are contained in the line only potentially, not actually. The line is one, whole, and undivided until its internal coherence is interrupted by a cut. Galileo, Two New Sciences, quoted from Stillman Drake's 235. Translation, London 1974, 42f, ridicules this idea in the following manner. Sal 6 ATI. I ask you to tell me boldly whether in your opinion the quantified parts of the continuum are finite or infinitely many. Simplicio, I reply to you that they are both infinitely many and finite, infinitely many before division, but actually finite in number after they are divided. For parts are not understood to be actually in their whole until after they are divided, or at least marked. Otherwise they are said to be potentially there. Salve, so that a line, 20 spans long, for instance, is not said to contain 20 units of one span each, actually, until after its division into 20 equal parts. Before this, it is said to contain these only potentially. Well, have this as you please and tell me whether, the actual division of such parts having been made, that original whole has increased, diminished, or remains still of the same magnitude. Simp. It neither increases or diminishes. Salve, so I think, too. Therefore the quantified parts in a continuum whether potentially or actually there, do not make it quantitatively greater or less. The implication of this little dialogue is that the lack of effect upon size makes the distinction between actual parts and potential parts meaningless. Stillman Drake, the translator and commentator, agrees. P 42 FN 27. Here Galileo proceeds to show the distinction is meaningless mathematically unless it affects quantity or magnitude. But a linear continuum in Aristotle's sense not only has extension, it has a structure, and this structure is changed by every division. Using a similarly superficial argument, one might say that there is no distinction between a liter of wine and a liter of water because both have the same volume. The objection that Galileo is speaking as a mathematician does not remove the difficulty, for it is just Aristotle's point that mathematical entities, apart from being extended, have also a structure, otherwise, there would be no difference between the number 5 and a line 5 inches long. Proposition 1 implies. Proposition 2, linear continuous manifolds, LCMs for short, are divisible into LCMs without limit and, further, that, 231b5ff Proposition 3, no point of an LCM can be a successor of another point of an LCM, for that would. 236. Assume that the un between the 2 points cannot be further divided. Propositions 1, 2, and 3 express an idea that is similar to the modem concept of an everywhere dense manifold. The difference is that the modem idea assumes the points as given while for Aristotle they are potential and have to be actualized by subdivision. 22. An undivided motion is an individual whole, without parts, and it is completed in a single step. The same is true of the distance covered and of the time it needs for the motion to occur. Dividing the motion means dividing the time and the distance, dividing the distance means dividing the motion and the time. We may conjecture that linear extension and time are LCMs just as motion is. Given the continuity of motion, length, and time, we can introduce a definition of quicker that was accepted in antiquity and was still used by Galileo. Quicker is what either covers a greater distance in the same time or the same distance in a smaller time or a greater distance in a smaller time. 232 at 23 ff. This is longer and much more clumsy than the corresponding modem definition. The clumsiness is intentional. Distance and time may have some abstract properties in common, continuity, divisibility, but they are not homogeneous magnitudes. 13. Therefore, they can only be related to themselves, distance to distance, time to time, motion to motion. Now consider two objects, one quicker, the other slower. Assuming that any motion can take place within any period of time, 232b21f, and that for any period of time there can be a distinction between faster and slower, 233b19f, we see, figures 7 and 8 and 233a8ff, that the faster will subdivide the time and the slower, the distance, thus establishing this, if length is continuous, so is time, and vice versa. This conclusion follows not only from what has just been said but also from the argument that the opposite assumption implies the divisibility of the indivisible, 233b16 ff. Assume, since velocities can stand in any relation, that one body covers the distance of while another body covers 2/3 of that distance in the same time, figure 9. Let the intervals equals ab equals bb be indivisible, and let the same be true of the corresponding times backslash rd equals d equals es. Then the slower body when arriving at the possible division A will divide the time at slash, thus dividing the indivisible. This supports the conjecture and shows the coherence of the notions used and the connections established. But there is no absolute proof of these notions and these connections. 23 Next, we have a sequence of theorems concerning the relation of time to motion and distance. Proposition 4, there is no motion in the now, 234-24. If there were motion in the now, there would be a faster motion and a slower motion, and the faster motion would divide the now in the manner described in the text discussion of figure 7. But the now is indivisible, 17. Proposition 5, neither can anything be at rest in the now, 234-33 f. Rest can be ascribed to an object only if that object is capable of motion. But there is no motion in the now. G. E. L. Owen, in an essay on the role of time in Aristotle's work, criticized these two propositions as being based on a false interpretation of common sense and as having hindered scientific progress. Scientific progress, he says, occurred only when functions connecting time and velocity were introduced and used in the calculation of the movements of bodies. The first criticism can be rejected when it is remembered that Aristotle's notion of continuity owes a debt to Parmenides, 16. 239. It is true that Aristotle occasionally uses homely examples such as glue and nails, 227-17, to illustrate continuity. But the content of the notion lies in its consequences, and among those consequences we have proposition 2, limitless divisibility, which can be proved only via a postulate of homogeneity such as the one proposed by Parmenides. The second criticism only shows that scientists can get very far by thinking very little. In 21, one quoted Galileo to the effect that what mattered was the length of a line, not its structure. This attitude served scientists well as long as the problems they encountered did not involve structure. Trouble arose in quantum mechanics, where considerations of structure became essential. In the attempt to resolve the problems connected with structure, physicists introduced ideas very similar to those expressed in propositions 4 and 5, uncertainty relations between time and energy, and can now be said to agree with Aristotle's principle that the motion of what is in motion and the rest of what is in rest must take time, 234b9f. This follows from the definition of place in 6 as the spatial correlate of propositions 4 and 5. The three propositions, and some others that are about to follow, are anticipated in Plato's discussion of the one, Parmenides 137 ff. This passage also contains material Aristotle seems to have used in his definition of continuity, c. 20. 24. According to 9, motion can be subdivided only by being brought to a temporary halt, the mobile must stop and begin to move again, 262-24 f. When the motion stops, the moving object is in a well-defined place and has well-defined properties, e.g., an object is gray when it was stopped on the way from white to black, 234b18f. Being in a well-defined place and having well-defined properties is the character of an object that does not move. Moving, therefore, implies not being in a well-defined place and not having well-defined properties. It seems that Aristotle, while occasionally drawing such a conclusion, cf. Proposition 14, was not always prepared to take this step, cf. the restriction, for as a whole the object cannot be in both the initial and the subsequent state of change or in neither 234bl7. He concludes, rather, that during the whole process of change the object must be partly under one condition and partly under another, i.e., it must be divided into parts that are in one condition and parts that are in another condition. Proposition 7, what changes is divisible, 234b10. Applied to locomotion, this means that we are dealing with elastic and deformable objects. Note the similarity to the relativistic account of the motion of extended objects. Proposition 8, whenever a change is completed, the changing thing is in the state into which it has changed. Literally, what has changed is that into which it has changed. 235b6ff. This simply follows from the meanings of the terms. Proposition 9, the primary time when what has changed has completed its change is indivisible. Assume it is divisible, and change occurs in both parts. Then the change has not yet come to an end. If change occurs in one part only, then we are not dealing with the primary time. 235b33ff. Propositions 8 and 9 are connected with the fact, emphasized in 11, that clearly marked stages of a motion are accompanied by an interruption of that motion. Now motion involves opposites. 189a10, one of the opposites is the for the sake of which or the aim, telos, of the motion. 194b33. When the aim is reached, the motion is completed and, therefore, interrupted, and the interruption provides an indivisible limit. 236a13, for the motion. Propositions 8 and 9 express this situation. Proposition 10, there is no indivisible primary time when what changes is completing its change. 239alf. The reason is that what is completing its change is in motion and, Proposition 4, there is no motion in an indivisible moment. In a similar manner, Proposition 5 yields Proposition 11. Proposition 11, neither is there an indivisible primary time in which rest first occurs. 239a10. Further, Aristotle's theory of mathematics 24:1. Proposition 12, everything that changes at a certain time changed before that time. Assume /15 to be the primary time for the change. The change must occur at a point A, in between A and B, but also at / in between A, and at C, in between B and A, and so on. Therefore, Proposition 13, there is no such thing as the beginning of a process of change. 236a13f. 25 The results of the preceding section may be summarized as follows. Every change is characterized by a well-defined indivisible moment, the primary moment when the change has been completed. There is no last moment when the change is still on, there is no first moment when the change starts, and there is no first moment of rest after the change has been completed. One might be inclined to regard this situation as a trivial consequence of the fact that a series of changes terminating in an aim is closed on the right and open on the left, and that it is everywhere dense. Cf. Chapter 4 of E. V. Huntington. The Continuum, Cambridge 1917. But the comparison is misleading in various respects. To start with, the structure of an Aristotelian line differs from the structure of a dense series. The elements of a dense series all exist and constitute the series. An Aristotelian line, on the other hand, is one and undivided until the parts are actualized by special means. Second, the end point of the change is actual not because all points of a change are actual and not because the change has been stopped by external means, but because of the particular way in which the change, every change, is completed. It arises because of the inner structure of the process of change. Third, it has no beginning because there is no motion in the now. The difference between the Aristotelian continuum and the mathematical continuum has been described with great clarity, but without reference to Aristotle, by Hermann Weyl in his essay Das Continuum, Leipzig 1919, p. 71. There is no agreement between the intuitive continuum, which is how Weyl describes the continuum viewed as an indivisible whole, and the mathematical continuum, which consists of points. Both are separated by an unbridgeable gulf. However, we have reasonable motives which, in our attempt to comprehend nature, make us 242. Move from the one to the other. They are the same motives that directed us from the world of human experience in which we live our normal lives towards a truly objective, precise and quantitative physical world behind experience, and that made us replace the color qualities of visible objects by ether vibrations. Our attempt to build up analysis from indivisible units may therefore be regarded as a theory of the continuum which has to be tested by experiment just as any other physical theory. The mathematical reconstruction of the continuum, Weyl says at a different place, über die neue Grundlagenkreis der Mathematik, Math. ZS. Volume 10, 1919, p. 42. Selects from the flowing goo, a heap of individual points. The continuum is smashed into isolated elements and the interconnectedness of all its parts replaced by certain relations between the isolated elements. When doing Euclidean geometry, it suffices to use the system of points whose coordinates are Euclidean numbers. The continuous space sauce that flows between them does not appear. This is Galileo's attitude, see the quotation in 21, except that Weyl is aware of the loss and of the possibility that its consequences may turn up in physics. The continuous space sauce may make itself noticed as we proceed into new domains of research. There are some physicists who think that it already appeared in microphysics. 26. According to propositions 4 and 5, there is neither motion nor rest in an instant, every motion fills an interval of time. The location of an object that moves in space is indeterminate in accordance with the size of this interval. If location is indeterminate, then so is length. Proposition 14, what moves has no well-defined length in the direction of the motion. Conversely, a definite length can be assigned to an object only if it can be made to cover a stationary measuring stick, i.e., if it is at rest. Being at rest takes time, proposition 5. Hence, proposition 15, an object can be said to have a well-defined length only if it is at rest for an interval of time, however small. 243-27. I conclude with a brief account of the way in which Aristotle solves Zeno's paradoxes of motion. Aristotle describes 4 such paradoxes, 239 below. His description is the earliest detailed account we have of Zeno's arguments. According to the first paradox, motion is impossible because before getting to a point the moving thing must first cover half the distance, then half of that half, and so on. One solution has been described in 9. Aristotle has a second solution, which he regards as less satisfactory, 263 of 4ff. According to the second paradox, the Achilles, the faster can never overtake the slower since the pursuer must first reach the point where the pursued started, so that the slower must always hold a lead. This Aristotle regards as a different version of the first paradox, and he solves it in the same manner. The third paradox, the arrow, states that, as a flying arrow at any moment of its journey occupies a place equal to its own dimensions, it is at rest at any moment of its journey and therefore at rest throughout the journey. The paradox is solved by reference to propositions 4 and 14. The fourth paradox, which is more difficult to interpret, is supposed to show that half the time is twice the time. There are, figure 10, 3 series of masses. A, B and C. A is at rest, and B moves to the right, C to the left, both with equal speed. While C passes all the B's, B passes only half of the A's. Assuming that passage of 2 masses takes the same time whether the masses are moving or at rest, we can say that B while passing half the S passes all the CS and therefore takes half the time, while the CS pass twice as many 5's as S and so take twice the time for the same process. Aristotle denies the assumption and so removes the paradox. Raphael Ferber, in an interesting and provocative book, Zenon's Paradoxien der Bewegung, Munich 1981, has suggested a connection between this paradox and some earlier versions of the idea that what is infinitely divisible has the same number of indivisibles no matter what the size. Today, this idea is illustrated by drawings such as figure 11. To every point of a B, there corresponds one and only one point of CD, and the 2 lines have an equal number of points. According to Arpad Szabo and Pnster Griechisch Mathematik, Budapest 1969, from whom Ferber quotes, Euclid Elements I. Axiom 8, the whole is bigger than the part, which in proofs is replaced by the stereotype otherwise what is smaller would be equal to what is larger, which is impossible, was introduced because some people denied it. No other reason can be imagined for formulating such an obvious principle. One person to deny the principle was Anaxagoras, Dioscrantz, B3. For any small thing there are things which are still smaller, for it is. 245. Velocity v. Time equals method of correlation. Figure 13. Impossible that being ceases. But also for what is big there is always something bigger and it is equal to the small in amount. Taken for itself, however, everything is both big and small. We may assume that this assertion underlying Anaxagoras' idea that every piece of material contains ingredients of everything else, there is flesh in metal, metal in air, air in bone, and so on, is also connected with Parmenides' assumption of the homogeneity of the one, introduced in 16 above. If the one is homogeneous throughout, then the smallest part has exactly the same structure as the whole, example it has the same number of parts, subdivisions. Is it possible to find an interpretation of the fourth paradox that leads to the same result? It is possible. See figure 12. Take any point of C, assumed to be continuous. When this point, say O, passes the right end ROFB, then R will be beneath P, halfway between R and O, and so P will correspond to O. Conversely, to every point sun A there is one and only one point on C, viz. that point that is IMS on the right of A caret. On a modem diagram, figure 13, the correlations become especially clear, the whole is mapped upon half of itself. Considering the definition in 15, we may conjecture that Aristotle might have accepted this result, provided that the mapping is between cuts that create points and not between pre-existing points. What consequences he would have drawn from it is a different question. Galileo and the Tyranny of Truth. This was a talk given, by tape, to the Pontifical Academy in Krakow, Poland. It has been largely rewritten, but I have retained the original style. A Baudelarized version of the talk was published in the Galileo Affair, a meeting of faith and science, edited by C.V. Coyne, M. Heller and J. Ziesinski, Vatican City 1985. Esteemed members of this conference. First let me apologize for not coming in person but sending an electronic representative instead. This representative, the tape I am preparing for you right now, will give you some of my opinions on the topic of the conference, but unfortunately it won't be able to reply to your questions or to answer your objections. The reason for my absence is a series of accidents which prevented me from getting my visa in time, and so I am sitting here, all by myself, in a small room, on top of a large building, with a view of the Swiss Alps, some green hills and Lake Zurich right in front of me. The landscape is wonderful, but, alas, there is not a single human face, which is somewhat of a disadvantage when you are supposed to be giving a talk. Still, I hope I will be able to make my presentation lively and interesting, and that I will also be able to anticipate which parts of my lecture you might receive not with a smile, nor with attentive curiosity, but with frowning disbelief. Those parts, naturally, I shall treat with special care. My second apology is about the way in which I am going to present my opinions. As far as I am concerned, the best way of 247. 248. Describing a historical conflict is to introduce the individuals that created it, to describe their temperament, their interests, their hopes and ambitions, the information at their disposal, their social background, the individuals and institutions they felt loyal to and that supported them in turn, and many similar things. Then one would have to explain how the individuals got entangled with each other and with the associated institutions, how they viewed the entanglement and how they reacted to it. One would have to explain, for example, how they used the power they possessed to reduce the entanglement and to make it serve their purpose. One would have to describe how the conflict was shaped by the legal and social laws of the time and the tensions between those laws and the temperament of the individuals, and so on. This, to my mind, would be the most desirable way of introducing a conflict such as the conflict between Galileo and the Church, but, alas, it can't be done. The material is much too voluminous to be surveyed in an hour and, besides, I know only a small part of it. I shall therefore use a different procedure to make my point. I shall rise to a higher level of abstraction. I shall not talk about individuals and their idiosyncrasies, I shall talk about traditions. I shall present the conflict between Giulio and the Church as a conflict between traditions, and I shall try to show that the tradition represented by the Church had interesting ancestors in antiquity and has progressive defenders today. Of course, speaking of traditions, or paradigms, or research programs, or themes, to use terms from more narrow fields than that before us, is a natural approach in history, sociology, and philosophy. I use the approach not because I am in love with it, but because of the difficulties just mentioned. So don't forget that we shall always be at least 2 steps removed from reality. The traditions I have in mind are traditions concerning the role of experts in society. In earlier writings, I have described 2 such traditions. One regards an expert as the final authority on the use and interpretations of expert views and expert procedures. The other subjects the pronouncements of experts to a higher court, which may consist either of super-experts, this was Plato's view, or of all citizens. This seems to have been recommended by Protagoras. I suggest that the opposition between Galileo and the Church was analogous to the opposition between what I have called the first and the second view, or tradition. Galileo was an expert in a special domain comprising mathematics and astronomy. In the classification of the time he was a mathematician and a philosopher. Galileo asserted that astronomical matters should be left to astronomers entirely. Only those few who deserved to be separated from the herd could be expected to find the correct sense of Bible passages dealing with astronomical matters, as he wrote in his letter to Castelli of December 14, 1613, Copernicus before him and Spinoza afterwards used similar language. This is an old topic, as Hans-Dieter Voigtlander, Der Philosophie und die Wielen, Wiesbaden 1980 shows, it occurs already in antiquity. In addition, Galileo demanded that the views of astronomers be made part of public knowledge in exactly the form in which they had arisen in astronomy. Galileo did not simply ask for the freedom to publish his results, he wanted to impose them on others. In this respect he was as pushy and totalitarian as many modern prophets of science, and as uninformed. He simply took it for granted that the special and very restricted methods of astronomers, and of those physicists who followed their lead, were the correct way of getting access to truth and reality. He was a perfect representative of what I have called the first view or tradition. The position of the Church, on the other hand, was very similar to the second view, in its Platonic, not its Protagorean version. Astronomical knowledge, according to the Church, was important and interesting, and it was actively pursued by some of its members. But the models which the astronomers produced to account, say, for the paths of the planets could not be related to reality without further ado. They arose from special and limited purposes, and all one could say was that they served these purposes, viz., prediction. Exactly this point is made in the first part of a famous letter which Cardinal Bellarmino, master of controversial questions at the Collegio Romano, wrote to Paolo Antonio Foscarini, a Carmelite monk from Naples, who had inquired about the reality of the Copernican system. The letter is often quoted, and even more often criticized by comparing its assertions with certain abstract principles which allegedly govern the practice of science. It looks very different when compared with this practice itself, as we shall see. In my opinion, it is a very wise document, and it contains sensible suggestions concerning the position of the sciences in our culture. Bellarmino writes. 250. It seems to me that your Reverence and Signer Galileo act prudently when you content yourselves with speaking hypothetically and not absolutely. To say that on the supposition of the Earth's movement and the Sun's quiescence all the celestial appearances are explained better than by the theory of eccentrics and epicecles is to speak with excellent good sense and to run no risk whatsoever. Such a manner of speaking is enough for a mathematician. But to want to affirm that the Sun, in very truth, is at the center of the universe and only rotates on its axis without going from east to west, is a very dangerous attitude and one calculated not only to arouse all scholastic philosophers and theologians but also to injure our holy faith by contradicting the scriptures. To use modem terms, astronomers are merely safe when saying that a model has predictive advantages over another model, but they get into trouble when asserting that it is therefore a faithful image of reality. Or, more generally, the fact that a model works does not by itself show that reality is structured like the model. This sensible idea is an elementary ingredient of scientific practice. Approximations are a commonplace in science. They are used because they facilitate calculations in a restricted domain. Their symmetry properties frequently differ from those of the underlying theory. Hence, if the theory is assumed to correspond to reality, the approximations cannot correspond to it in the same sense. Theories, on the other hand, are often developed as steps towards a more satisfactory but as yet unknown view. They may be successful, but the very purpose for which they were introduced forbids us to draw realistic consequences from them. The older quantum theory is an example, and so was Newton's theory of gravitation, at least as Newton saw it. Even a formally perfect theory with surprising predictive powers may fail when regarded as a direct expression of reality. Schrödinger's wave mechanics illustrates this further point. It was elegant, coherent, easy to handle, and it was remarkably successful. Schrödinger inferred that elementary particles were waves. Yet looking at a wider range of phenomena, Bohr and his school showed that this interpretation conflicted with important facts. There are also two formal obstacles, viz. The so-called reduction of the wave packet and the fact that the theory is not Lorentz invariant. And now take the best theories of modem physics, general relativity in its most recent form and general quantum mechanics. So far it has proved impossible to merge them into a coherent whole. The one theory makes assertions which are flatly contradicted by the other. Can we still assert that we get a correct description of reality from either of them? We cannot. We can say that both theories are useful approximations, but we have no idea what the reality they approximate looks like. All these examples have immediate application to the case of the Cope-Mikan theory, whose coherence and partial success were also regarded as signs of a close correspondence to reality, both by its author and by writers such as Rheticus and Maslin. For the Cope-Mikan theory was not the only cosmological view in existence and not even the most general one. Hence its success and the coherence of its structure, taken by themselves, did not yet mean agreement with reality. To show such agreement it was necessary to move to a wider domain. In modem science the wider domain chosen very often is elementary particle physics. Scientists working in this field agree that chemists, biologists, rheologists etc. may have discovered some interesting regularities, but they deny that these regularities are basic features of reality. Some modem biologists similarly look askance at things such as botany and bird watching, asserting that the only real information about the life process comes from molecular biology. In his search for a way out of the difficulties of early 20th century science, Einstein relied on thermodynamics. In all these cases models are compared with basic science and their realistic implications are judged accordingly. What was the wider domain that determined reality for the Church? According to Bellarmino, the wider domain contained two ingredients, one scientific, philosophy and theology, one religious and to that extent normative, our holy faith. The first ingredient differed from modern measures of reality, molecular biology, elementary particle physics, cosmology, in content but not in function. Philosophy meant mainly the Aristotelian opus, which included a general theory of change and motion, a theory of the mathematical and physical continuum. The theory is described in chapter 8 of the present book, a theory of elements and some considerations concerning the structure of the world. Theology dealt with the same subject matter but viewing it as a creation, not as a self-sufficient system. It was and still is a science, and a very rigorous science at that. Textbooks in theology contain long methodological chapters, textbooks in physics do not. The second ingredient means that scientific results, wrongly interpreted, may injure human beings. This ingredient, too, is 252. Still with us. Modern defenders of science frequently warn us that a misleading presentation of scientific results or of basic scientific conflicts may lead to irrationalism and thus injure our holy faith in reason. Conversely, opponents of reductionism try to interpret scientific results in a manner that no longer violates their holy faith in the integrity of nature, cultures, and individual human beings. The difference between Bellarmino's version and the modern versions is twofold. Most modem versions have ceased relating their faith, in reason, in the integrity of human beings, etc., to a divine creator, and the institutional backing of the older warnings was stronger than is the institutional backing of reason or of anti-reductionism today. This last difference, however, reflected not the Church, but the entire age. And let us not forget that many modem rationalists try to increase the power of reason by increasing the power of the institutions that support it. The second ingredient, as presented by Bellarmino, further implies that questions of fact and reality depend on questions of value. For a positivist this is an unfamiliar and even repulsive idea, but only because he is not aware of his own normative prejudices. A brief look at the history of the concept of reality reveals what these prejudices are. In Homer, events such as dreams, the actions of gods, or illusions were all regarded as being equally real. I put the phrase in quotation marks because the notion of reality that occurs in it already assumes that some things may not be as real as others. No separation existed between a reality outside human beings and the result of a perceiving and distorting agency within. Simplifying the situation somewhat, we may say that this was so because there was no mind, there was no special region, no subject that contained events set off from the rest of the world, and capable of distorting it. Anaximander then based all cosmic processes on the changes of a single substance, the apeiron. Dreams, gods, premonitions had no place in this world, they became homeless. What was to be done with them? The answer was given by Parmenides, who introduced a sharp distinction between two kinds of things and processes, real things on the one side, mere appearances on the other. Reality was constituted by novel procedures that differed both from tradition and from simple observation. Appearances were attributed to an erring mind, thus the mind arose partly as a receptacle for all those things that could not be accommodated in the real world. Accepting some phenomena as real and rejecting others as deceptive therefore meant choosing one tradition over another. This became very clear later on, when Gnostics and naturalists quarreled about the reality of matter, and it is apparent even today when some scientists claim to have discovered an ultimate reality, elementary particles and their fields, while others emphasize large-scale laws and regard high-energy physics as a rather expensive and complicated version of stamp collecting. Aristotle described the situation in wonderfully simple terms when defending the reality of non-Parmenidean things and processes with the remark that they were essential for life in the city, even if there should exist a single goodness which is universally predicible of goods, or is capable of separate and independent existence. Clearly it could not be achieved or attained by man, but we are seeking something attainable. Nicomachean Ethics, 1096b 32f, my emphasis. He also emphasized, in his book on the soul, that materialistic, psychological and sociological accounts of the soul, serving different purposes, were all correct in their respective domains. Thus the Church was not only on the right track when measuring reality by human concerns, but it was considerably more rational than some modem scientists and philosophers who draw a sharp distinction between facts and values and then take it for granted that the only way of arriving at facts and, therefore, reality, is to accept the values of science. At the time of Galileo, one important source for the discussion of human concerns was the Bible. It still retains this position in our own times. The Church, being the foremost guardian and interpreter of the Bible, also made it a boundary condition of reality. Newton, who opposed Catholicism, still took this boundary condition very seriously. Research, according to Newton, must use two sources, the works of God, the magnificent universe, and the Word of God, the Bible. Details of the Bible, such as the story of the flood, were used by scientists to support scientific views until well into the 19th century, catastrophism. The Church not only used the Bible as a boundary condition of truth and reality, it also tried to impose it by administrative measures. Bellarmino is very clear on this point. As you are aware, the Council of Trent forbids the interpretation of the Scriptures in a way contrary to the common opinion of the Holy Fathers. It is here that the modem reader, and especially the liberal epistemologist who is familiar with some abstract desiderata but has never seen science from nearby, is liable to throw up his hands in despair. To his mind, knowledge has nothing to do with administration, and his heart goes out to poor Galileo, who had to put up with such nonsense. But it is not at all certain that a modem Galileo would have an easier life. Assume, for example, that he wanted to test the efficacy of modem scientific medicine by using control groups of volunteers treated by alternative methods. Then, in many states of the USA he would be visited by the POHCE, just as Galileo was. Assume he wants to teach evolution and Genesis on equal terms, as two alternative accounts of the origin of human beings. Then he MNS into another legal restriction, namely the separation of state and church, which puts strong legal and administrative limits on the transmission of knowledge claims. Evolution is to be taught as a fact, or as a theory dealing with facts, while Genesis can at most be taught as a belief. This is an inversion of Bellarmino, who assigned the determination of basic facts to philosophy and theology and granted science at most an instrumental role, a further confirmation of the point, made above, that reality is a value-laden term and that questions of reality are closely connected with human concepts. Our modem Galileo will also find that arguments only rarely suffice to get an idea accepted and financed. The idea must fit the ideology of the institute that is supposed to absorb it and must agree with the ways in which research is done there. And there is no individual human being to whom he could explain his suggestions and whom he could educate in his own ways of thinking. There are anonymous committees, often stacked with incompetents who regard their own ignorance as a measure of things. How can an intelligent person succeed in such circumstances? It is very difficult. Galileo tried to combine philosophy, astronomy, mathematics, and a variety of subjects which are best characterized as engineering into a single new point of view, which also entailed a new attitude towards Holy Scripture. He was told to stick to mathematics. A modem physicist or chemist trying to 255 reform nutrition or medicine faces similar restrictions. A modem scientist who publishes his results in a newspaper or who gives public interviews before he has submitted to the scrutiny of the editorial board of a professional journal or of groups with comparable authority has committed a mortal sin which makes him an outcast for quite some time. Admittedly, the control is not as tight as it was at the time of Galileo and not as universal, but this is the result of a more easygoing attitude towards certain crimes. Thieves, for example, are no longer hanged or mutilated, and not a change of heart as to the nature of the crimes themselves. The administrative restrictions on a modem scientist are certainly comparable to those in force at Galileo's time. But while those of the older restrictions which issued from the Church were available in the form of explicit rules, such as the Miles of the Tridentine Council, modern restrictions are often implied, not spelled out in detail. There is much insinuating and hinting, but there is no explicit code one could consult and, perhaps, criticize and improve. Again, the procedure of the Church was more straightforward, more honest, and certainly more rational. And now comes a very important point: this straightforward and rational boundary to research was not immovable. This is what Bellarmino says very clearly in the last part of his letter. If there were any real proof that the sun is in the center of the universe and that the earth is in the third heaven, and that the sun does not go round the earth but the earth round the sun, then we would have to proceed with great circumspection in explaining passages of Scripture which appear to teach the contrary, and rather admit that we did not understand them than declare an opinion to be false which is proved to be true. Church doctrine, Bellarmino says here, is a boundary condition for the interpretation of scientific results. But it is not an absolute boundary condition. Research can move it. However, Bellarmino continues, as for myself, I shall not believe that there are such proofs until they are shown me. Nor is it a proof that, if the sun be supposed at the center of the universe and the earth in the third heaven, everything works out the same as if it were the other way around. In case of doubt, we ought not to abandon the interpretation of the sacred text as given by the Holy Fathers. The idea expressed in the last sentence is today accepted by all high school principals and even by some university presidents. Don't introduce a new basis for education until you are sure it is at least as good as the old basis. It is also a reasonable idea. It advises us to make basic education independent of fashions and temporary aberrations. Education is not just ideas. It is textbooks, skills, equipment for demonstrations, laboratories, fibs, slides, courses for teachers, computer programs, problems, examinations, and so on. When built up in a judicious way, it can accommodate fashions, aberrations and alternative views and thereby illuminate the process of scientific research. However, it would be very unwise to rebuild it from top to bottom whenever an adventurous new point of view appears on the horizon. Besides, one would not know how to proceed. There always exist many conflicting fashions, aberrations, suggestions, bold ideas. The Church took that into account. It demanded strong arguments before it would consider changing an important piece of knowledge. But was Bellarmino perhaps dragging his feet? Did he resist in the face of clear and unambiguous evidence? Or, even worse, was he perhaps not informed about the evidence that existed at the time? This technical question, unfortunately, has become the question for many investigators. I shall attack the problem connected with it by asking a different question: what would have been the judgment of modern scientists and philosophers of science had they been transferred into the early 17th century and asked the question Bellarmino was asked, namely, what's your opinion of Copernicus? The answer is that different people would have said different things. Science, like any other enterprise, knows hardliners and it knows more tolerant people. There are scientists who read the success of a theory in small hints, and there are other scientists who want more substantial proofs. There are scientists who are satisfied with simplicity and intellectual harmony, there are other scientists who want solid empirical backing. There are scientists who are frightened by inconsistencies in a theory or 257. Between theory and experiment, and there are other scientists who regard such inconsistencies as natural companions of progress. Michelson and Rutherford never fully accepted relativity, Poincare, Lorentz, and Ehrenfest became doubtful after Kaufmann's experiments, while Planck and Einstein, convinced by its internal symmetry, were more persistent. Sommerfeld was very successful in making the older quantum theory as formidable as classical celestial mechanics, while Bohr, despite the successes achieved, thought that Sommerfeld was on the wrong track. Pauling loved confusing his colleagues with conjectures taken from simple model building, while they preferred pondering the intricacies of X-ray photographs. Who knows what any of them would have said if transported back to Bellarmino's desk? Michelson, presented with Galileo's telescopic observations, might have pointed to their internal contradictions: the planets are pulled towards the observer, the fixed stars are pushed away, the inside of the moon shows mountains while its circumference is perfectly smooth, and he might have laughed at the attempt to get physical information from an instrument so little understood. And almost all philosophers of science writing today would have agreed with Bellarmino that Copernicus's case was very weak indeed. The strongest argument mentioned by Copernicus, Rheticus, and Maslin, an argument which convinced Kepler, was the harmony created by the Copernican point of view. For the first time there was an astronomical system and not only a set of calculating devices. But the argument can lead astray, as the case of Schrödinger shows. The correct interpretation of a simple and harmonious point of view may differ considerably from the interpretation suggested by a first and superficial look at it. Galileo was aware of the problem. Why else would he have given such weight to his decisive proof, the theory of the tides? Besides, the elements of mechanics he succeeded in contriving during his lifetime were quite inadequate for providing a dynamics of the planetary system as described by Copernicus. He might have supported circles, but they made nonsense of the epiclecles that were still needed for correct predictions, and they were inapplicable to Kepler's laws, which Galileo did not accept anyhow. An acceptable solution came later, with Newton, and even he needed divine interventions to keep the planetary system in order. Besides, Galileo's views on the relativity of motions were incoherent. Occasionally he asserted the relativity of all motion, on other occasions he accepted impetus, which assumes a fixed reference system. Galileo's basic physics was even worse. Aristotle had provided a general theory of change, motion, and the continuum. The theory dealt with locomotion, qualitative change, generation, and corruption, and it gave an account of falling stones as well as of the transmission of information from a teacher to an attentive student. The theory of locomotion was very sophisticated, entailing that an object cannot move and at the same time have a precise position. Galileo restricted himself to locomotion, and even here used terms much more simple-minded than those already introduced by Aristotle. Aristotle had made a step towards the quantum theory, which regards motion as an indivisible whole, while Galileo moved away from that achievement. As a consequence, biologists, physiologists, Harvey, the founders of the new science of electricity, and bacteriologists continued to use Aristotelian ideas until late into the 18th century, and to some extent, even right into the 20th century. Prigogine has some very nice things to say about Aristotle. Newton certainly took Aristotle's comments on motion seriously, as can be seen from his manuscripts. Einstein, with his contempt for a verification of little effects and with his uncanny ability to divine future splendors in a present mess, might have taken the side of Copernicus, but many other physicists would have thrown up their hands in despair. Bellarmino's judgment, therefore, is an entirely acceptable point of view. With this I conclude my brief description of the form two ancient traditions had assumed at the time of Galileo. The traditions dealt with the role of science in society. According to the first tradition, society must adapt to knowledge in the shape presented by the scientists. The tradition was defended by Galileo. It was used more recently by scientists as a basis for negotiations with the Church after Cardinal Koenig of Vienna had suggested a closer cooperation. Cooperation, the representative of the physicists said, means that scientific concepts are not reinterpreted and used in a different sense from that of the scientists, and that the principles of the Church be made consistent with the findings of the natural sciences. This is Bellarmino's position, except that expert knowledge from a special and rather narrow domain has now taken the place of the wider and more humanitarian point of view of 17th-century Catholicism. According to the second tradition, scientific knowledge is too specialized and connected with too narrow a vision of the world to be taken over by society without further ado. It must be examined, it must be judged from a wider point of view that includes human concerns and the values flowing therefrom, and its claims to reality must be modified so that they agree with these values. For example, pain, the feelings of friendship, fear, happiness, and the need for salvation, either in secular terms or in terms of some transcendent realm of being, play a large role in human lives. They are basic realities. Hence the claims of some elementary particle physicists to have found the ultimate constituents of everything have to be rejected and replaced by a more instrumentalistic position. Their theories are not about reality, they are about predictions in a reality determined independently of their efforts. At the time of Galileo, this second tradition was the tradition defended by the Church. The Church used its Platonic version. The wider knowledge was expert knowledge, but being connected with an eminently human document, the Bible, it had and still has a tremendous advantage over the principles of an abstract rationalism. It is also true that the noble sentiments inherent in a knowledge of this kind did not always prevail, and that some church directives were simply an exercise in power. But the better representatives of the Church thought differently and were worthy predecessors of modern attempts to temper the totalitarian and dehumanizing tendencies of modern scientific objectivism by elements directly taken from human life and to that extent subjective. It must also be admitted, as I have acknowledged, that infringements of epistemological rules are today rarely a matter for the police. However, the law still intrudes. The idea of free and independent research is a chimera, and the presence or 260. Absence of police intervention has nothing to do with the problem before us, namely the interpretation of scientific knowledge claims. Besides, we have seen, see the brief quotation after footnote 7 above, that even the liberal climate of the modern age has not prevented scientists from demanding the same kind of authority which Bellarmino possessed as a matter of course but exercised with much greater wisdom and grace. It is a pity that the Church of today, frightened by the universal noise made by the scientific wolves, prefers to howl with them instead of trying to teach them some manners. Finally, a few words about the assertion of some scientists and philosophers that science needs no supervision because it is inherently human and self-correcting. Whatever errors scientists commit, these people tell us, scientists correct, they do so better than any outsider could, and they should therefore be left alone, except of course for a steady influx of the millions they need to pay for their corrections. It is easy to show the flaws in this assertion. It is of course true that science is inherently human and that a scientist can be as kind or as nasty as the next person. The trouble is that increasing competition inside the scientific establishment, and the increasing attention that is given to the pronouncements of scientists, tend to encourage selfishness, conceit, and a contempt for people for the herd, as Galileo called them who cannot follow the subtle contortions of noble minds. The institutionalization of matters previously in the hands of individuals and small groups also encourages opportunism and cowardice. Earlier scientists who were members of religious communities knew that sub specie imitatis their achievements counted for little. Those modern scientists who combine scientific curiosity with a love for nature and their fellow human beings to some extent share the sense of perspective of their religious predecessors, but they are surrounded by people with very different ideas. Has science the capability of correcting the aberrations that might arise in a complex enterprise of this kind? Of course it has. There exists no enterprise that is not self-correcting to some extent and that cannot be changed by the actions of even a few determined individuals. But science is part of larger units, it is part of a city, a region, of entire nations. Depending on their political structure, these larger units, too, may be self-correcting. Democracy, especially ancient Greek democracy, was ready to correct everything that occurred in its midst, the effusions of experts included. But democracy, according to the position I am discussing now, has no business interfering with the work of science. Why? One reason given is that this work is much too complex to be understood by laymen. The same can be said about interdisciplinary work within the sciences, and yet such work is encouraged and its results are praised. Many scientists in defending their results use arguments that make a philosopher's hair stand on end, and yet the arguments are accepted and science proceeds on their basis. Besides, institutions such as trial by jury and citizens' initiatives show that lay people can be instructed, or can instruct themselves, about recondite matters and can in this way acquire the knowledge needed for a balanced judgment. The legalization of acupuncture in California was the result of a learning process of this kind. A second defense of scientific autonomy is that science is objective and should thus be separated from the subjective opinions of politics. This is an old defense, it can be found in Plato. But a democracy cannot simply bow to the assertions of scientists and philosophers, it must examine these assertions, especially when they touch on fundamental matters. For example, it must examine this claim of objectivity. In other words, it must enter upon a philosophical analysis of scientific claims just as it must enter on a financial analysis of local and national budgets. And in entering upon such an analysis it will have to rely not just on objective truths, but on the way in which these truths present themselves to its members, i.e. it will have to rely on the subjective judgments of these members. To sum up this part of the argument, science, which is self-correcting, is part of larger units which are also self-correcting. In a democracy the self-correction of the larger units includes all their parts, which means that democratic self-correction overrules the temporary results of scientific self-correction. Self-correction includes a critique of limitless change. The sciences have by now left the qualitative world of our everyday experience far behind. Some scientists claim that this world is a mere appearance and that reality lies elsewhere. They see human beings in terms of this reality and approach them accordingly. But human beings may object to such treatment. They may declare themselves to be a reality different from reality as defined by scientists and may decide to stabilize the former. For example, they may decide to stabilize the qualitative world of our everyday experiences and regard every deviation from it as a step into inhumanity. This is how decisions about the quality of our lives can determine what is to be regarded as real and what is to be regarded as an appearance or a mere instrument of prediction. The enthusiasm for criticism shown by the philosophers and scientists whose views I am discussing now, though shared by many intellectuals, is not the only basis for a rich and rewarding life, and it is very doubtful if it can even be a basis. Human beings need surroundings that are fairly stable and give meaning to their existence. The restless criticism that allegedly characterizes the lives of scientists can be part of a fulfilling life. It cannot be its basis. It certainly cannot be a basis of love, or of friendship. Hence, scientists may contribute to culture, but they cannot provide its foundation and, being constrained and blinded by their expert prejudices, they certainly cannot be allowed to decide, without control from other citizens, what foundation the citizens should accept. The churches have many reasons to support such a point of view and to use it for a criticism of particular scientific results as well as of the role of science in our culture. They should overcome their caution, or is it fear, and revive the balanced and graceful wisdom of Roberto Bellarmino, just as scientists constantly gain strength from the opinions of Democritus, Plato, Aristotle, and their own pushy patron saint, Galileo. Appendix. The following is a letter I wrote, in German, to one of the participants of a debate on the modern relation between the sciences and the Catholic Church. Dear Father Rupert, I listened with interest to your talk of Thursday last. I was surprised by two features. The one is the speed with which the Church now retreats in the face of scientific results. This phenomenon does not exist within the sciences, although there is much opportunism even here. It often happens that a scientific point of view is shown to be erroneous, but its defenders do not give up, they pursue it for decades, even for centuries, and it often turns out that they are right. The atomic theory is one example. It was frequently refuted, but it always returned and defeated its Death Eaters. Towards the end of the 19th century, some continental physicists regarded it as a metaphysical monster. The theory was in conflict with facts and internally incoherent. Still its defenders, Boltzmann and Einstein among them, persevered and finally led it to victory. Now, if it is legitimate to hold on to and to defend refuted views within the sciences, if such a procedure can lead to scientific progress, why, then, does the Church hesitate to do the same thing from the outside? For the situation, certainly, is very similar. One of the first scientific attacks against the doctrines of the Church was based on Aristotle's arguments against an origin of the universe. These arguments had much in common with modern cosmological arguments. They rested on known and highly confirmed natural laws and extrapolations therefrom. Long after Aristotle, the eternity of the material world as we know it was regarded as a basic fact of science, and then science changed. Today there are numerous world models postulating a beginning in time and leading to complex creations during the first world minutes. The restraint, not to say fearfulness, of the Church, therefore, cannot be excused by pointing to scientific practice. It rests on an ideology pure and simple. Which brings me to the second point. You have said that what matters is not so much a certain physics or cosmology but the relation of human beings to God, and you have said that this relation has much in common with love. Now, love in the countryside differs from love in the city, and there are situations where love becomes almost impossible. For example, love becomes impossible for people who insist on objectivity, i.e. who live entirely in accordance with the spirit of science. The sciences encourage objectivity, even demand it, they thereby reduce our ability to love, except in a very intellectual way, which means that a person who wants to disseminate love cannot forget the sciences, he must deal with them and fight certain tendencies inherent in them. 264. When I was a student I revered the sciences and mocked religion, and I felt rather grand doing that. Now that I take a closer look at the matter, I am surprised to find how many dignitaries of the Church take seriously the superficial arguments I and my friends once used, and how ready they are to reduce their faith accordingly. In this they treat the sciences as if they, too, formed a church, only a church of earlier times and with a more primitive philosophy, when one still believed in absolutely certain results. A look at the history of the sciences, however, shows a very different picture. Best wishes. Paul Feyerabend. 1 in his book Reason, Truth, and History, Cambridge 1981, p. 114, Hilary Putnam asserts that both of the two most influential philosophies of science of the 20th century are self-refuting. The philosophies he has in mind are logical positivism and the historical approach. I shall discuss an idea that belongs to the latter, viz. incommensurability, and I shall show that while the idea may have unusual consequences, self-refutation is not one of them. 2. According to Putnam, the incommensurability thesis is the thesis that terms used in another culture, say, the term temperature as used by 17th century scientists, cannot be equated in meaning and reference with any terms or expressions we possess, p. 114. I shall call the incommensurability thesis as defined in this statement I. To refute I, Putnam points out, a. that if I were really true, then we could not translate other languages, or even past stages of our language, at all, p. 114, adds, b. that if Feyerabend were right, then members of other cultures, including 17th century scientists, would be conceptualizable by us only as animals producing responses to stimuli, and concludes, c. to tell us that Galileo has incommensurable notions and then to go on and to describe them at length is totally incoherent, p. 114f, Putnam's italics. 3a, b and c rest on the following two assumptions. I. Understanding foreign concepts, foreign cultures, requires translation, and 2. A successful translation does not change the translating language. These two assumptions are characteristic of theoretical traditions, and Putnam's arguments, therefore, provide a very good illustration of the general observations made in Chapter 3. Neither I nor 2 is correct. We can learn a language or a culture from scratch, as a child learns them, without detour through our native tongue. Linguists, historians, and anthropologists, having realized the advantages of such a procedure, now prefer field studies to the reports of bilingual informants. And we can change our native tongue so that it becomes capable of expressing alien notions. Successful translations always change the medium in which they occur. The only languages satisfying to are formal languages and the languages of tourists. Modem lexica exploit both possibilities. Instead of the semantic equations that formed the basis of older dictionaries, they employ research articles of an open and speculative nature. See, for example, the introduction and the major research articles in Bruno Snell et al., Lexikon de Freie Griechisken Epos, Göttingen 1971. Analogies, metaphors, negative characterizations, bits and pieces of cultural history are used to present a new semantic landscape with new concepts and new connections between them. Historians of science proceed in a similar way, but more systematically. Explaining, say, the notion of impetus in 16th and 17th century science, they first teach their readers the physics, metaphysics, technology, and even the theology of the time. In other words, they too introduce a new and initially unfamiliar semantic landscape, and then show where impetus is located in it. Examples are found in the work of Pierre Duhem, Annelies Mayer, Marshall Clagett, Hans Blumenberg and, for other concepts, Ludwig Fleck and Thomas Kuhn. Translating a language into another language is in many ways like constructing a scientific theory. In both cases we must find concepts that fit the language of the phenomena. In the natural sciences the phenomena are those of inanimate nature. Nobody doubts that it is difficult to give a general account of them, that we may have to revise the terms with which we started, and that we may have to revise them further when new phenomena appear. In the case of translation, the phenomena are the ideas implicit in another language. These ideas developed in different and often unknown geographical surroundings and under different and often unknown social circumstances, and they went through numerous intended and unintended changes, influence of further languages, deterioration, poeticence, etc. Putnam's 2 assumes that every language contains everything that is needed for dealing with all these eventualities. To use an example, it makes the rather unlikely assumption that modem Swahili is already adapted to the language of the Eskimo and, therefore, to Eskimo history. There are only 2 ways in which such an assumption could succeed: a priorism, or pre-established harmony. Being an empiricist, I reject both. For according to Putnam, I makes it impossible to explain foreign, primitive, technical, ancient, concepts in English. This is the content of C. He is right in one sense, wrong in another. It is indeed impossible, and trivially so, to formulate ideas in a language not fit to receive them. But the criteria which identify a natural language do not exclude change. English does not cease to be English when new words are introduced or old words given a new sense. Every philologist, anthropologist, or sociologist who presents an archaic, primitive, exotic, etc., worldview, every popular science writer who wants to explain unusual scientific ideas in ordinary English, every surrealist, Dadaist, teller of fairy tales or ghost stories, every science fiction novelist and every translator of the poetry of different ages and nations knows how first to construct, out of English words, an English-sounding model of the pattern of usage he needs and then to adopt the pattern and to speak it. A rather trivial example is Evans Pritchard's explanation of the Azanda word mbizimo, designating the ability of their poison oracle to see far off things. In his book Witchcraft, Oracles, and Magic Among the Azanda, abridged edition, Oxford 1975, p. 55, Evans Pritchard translates mbizimo as soul. He adds that it is not soul in our sense, implying life and consciousness, but a collection of public or objective events. The edition modifies the use of the word soul and makes it more suitable for expressing what the Azanda had in mind. Why soul and not another word? Because the notion this word expresses in our own culture is nearer to the Zanda notion of mbizimo of persons than any other English word, i.e. because of an analogy between the English soul and the Azanda mbizimo. The analogy is important for it smooths the transition from the original to the new sense. We feel that despite the change of meaning we are still speaking the same language. Now if a conceptual change like the one just described does not go through a meta-language but stays in the language itself, in which case we would speak of changing the properties of things rather than the usage of words, and if it is not only a single term but an entire conceptual system that is being received, then we have the situation alluded to in C, but diffused. For the English with which we start is not the English with which we conclude our explanation. 5. Azanda ideas already exist in a spoken language and English notions were changed to accommodate them. There are other cases where linguistic change introduces a novel and as yet unexpressed point of view. The history of science contains many examples of this kind. I shall explain the matter by taking an example from the history of ideas. In Iliad 9, 225 ff, Odysseus tries to get Achilles back into the battle against the Trojans. Achilles resists. Equal fate, he replies, befalls the negligent and the valiant fighter, equal honor goes to the worthless and to the virtuous, 318 f. He seems to say that honor and the appearance of honor are two different things. The archaic notion of honor did not allow for such a distinction. Honor as understood in the epic was an aggregate consisting partly of individual and partly of collective actions and events. Some of the elements of the aggregate were, the position, of the individual possessing or lacking honor, in battle, in the assembly, during internal dissension, his place at public ceremonies, the spoils and gifts he received when a battle was finished and, naturally, his behavior on all these occasions. Honor was present when, most of, the elements of the aggregate were present, absent otherwise, cf//12, 310 ff, Sarpedon's speech. Achilles introduces a different point of view. He was offended by Agamemnon, who had taken his gifts. The offense created a conflict between the individual and the collective ingredients of honor. The Greeks who appeal to Achilles, Odysseus among them, illustrate the customary resolution of the conflict. Achilles' gifts have been returned, more gifts have been promised, harmony has returned to the aggregate, honor has been restored. 519, 526, 602f. So far we are squarely within tradition. Achilles moves away from it, pushed along by his lasting. 269. Anger, he perceives an equally lasting imbalance between personal worth and social rewards. What he has in mind not only differs from the traditional aggregate, it is not even an aggregate, for there is no set of events that guarantees the presence of honor as he now sees it. Using Putnam's terminology, we can say that Achilles' idea of honor is incommensurable with the traditional idea. And indeed, given the epic background, the short excerpt I quoted from Achilles' speech sounds as nonsensical as the statement equal time needs the fast and the slow to reach the goal. Yet Achilles introduces his idea in the very same language that seems to exclude it. How is that possible? It is possible because, like Evans Pritchard, Achilles can change concepts while retaining the associated words. And he can change concepts without ceasing to speak Greek because concepts are ambiguous, elastic, capable of reinterpretation, extrapolation, restriction. To use a term from the psychology of perception, concepts like percepts obey figure-ground relations. For example, the tension between the individual and the collective elements of honor that was caused by Agamemnon's deed can be seen in at least two ways: as involving ingredients of equal weight, or as a conflict between fundamental and more peripheral elements. Tradition accepted the first view, or, rather, there was no question of a conscious acceptance, people simply acted that way. With gifts promised go forth. The Achaeans will honor you as they would an immortal. 602f. Achilles, driven by his anger, magnifies the tension so that it turns from a transitory disturbance into a cosmic rift. Figure-ground relations often change as a result of strong emotions. This is the principle of the Rorschach test. The extrapolation does not void his speech of meaning because there exist analogies for what he is trying to express. Divine knowledge and human knowledge, divine power and human power, human intention and human speech, an example used by Achilles himself, 312f, are opposed to each other as Achilles opposes personal honor and its collective manifestation. Guided by the analogies, Achilles' audience is drawn into the second way of seeing the tension and so discovers, as Achilles did, a new side of honor and of archaic morality. The new side is not as well defined as the archaic notion, it is more a foreboding than a concept, but the foreboding produces new ways of speaking and thus, eventually, clear new concepts. The concepts of some pre-Socratic philosophers are endpoints of this line of development. Forebodings are excluded from theoretical treatise. 270. Which therefore either block conceptual change or cannot account for it once it has taken place. Thus if we take the unchanged traditional concepts as a measure of sense, we are forced to say that Achilles speaks nonsense. C.F.A. Perry's account in the language of Achilles, Transactions and Proceedings of the American Philosophical Association, Volume 87, 1956, and my own comments in Against Method, p. 267. But measures of sense are not rigid and unambiguous, and their changes are not so unfamiliar as to prevent the listeners from grasping what Achilles has in mind. Speaking a language or explaining a situation, after all, means both following rules and changing them. It is an almost inextricable web of logical and rhetorical moves. From what has just been said, it also follows that speaking a language goes through stages where speaking indeed amounts to merely making noises. Putnam, 122. For Putnam this is a criticism of the views he ascribes to Kuhn and myself, cf. Section 2, Objection B of the present chapter. For me it is a sign that Putnam, because of his bias in favor of theoretical traditions, is unaware of the many ways in which language can be used. Little children learn a language by attending to noises which, being repeated in suitable surroundings, gradually assume meaning. Commenting on the explanations which his father gave him about questions of logic, Mill writes in his autobiography, quoted from Max Lemmer, ed., Essential Works of John Stuart Mill, New York 1965, p. 21. The explanations did not make the matter clear to me at the time, but they were not therefore useless, they remained as a nucleus for my observations and reflections to crystallize upon, the import of his general remarks being interpreted to me, by the particular instances which came under my notice afterwards. Saint Augustine advised parsons to teach the formulae of the faith by rote, adding that their sense would emerge as a result of prolonged use within a rich, eventful, and pious life. Theoretical physicists often play around with formulae which do not yet make any sense to them until a lucky combination makes everything fall into place. In the case of the quantum theory, we are still waiting for this lucky combination. And Achilles, by his way of talking, created new speech habits which eventually gave rise to new and more abstract conceptions of honor, virtue, and being. Thus using words as mere noises has an important function even within the most advanced stages of speaking a language, cf. My Against Method, p. 270. One scientist who was aware of the complex nature of X-plan. 271. Aeteri talk and who used its elements with superb skill was Galileo. Like Achilles, Galileo gave new meanings to old and familiar words. Like Achilles, he presented his results as parts of a framework that was shared and understood by all. I am now speaking of his change of basic kinematic and dynamical notions, but unlike Achilles, he knew what he was doing and he tried to conceal the conceptual changes he needed to guarantee the validity of his arguments. Chapters 6 and 7 of my book Against Method contain examples of his art. Taken together with what I have said here, these examples show how it is possible to assert, without becoming incoherent, that the Galilean notions are incommensurable with our own, and then to go on and to describe them at length. 6. They also solve Putnam's conundrum about the relation between relativity and classical mechanics. If I is correct, says Putnam, then the sense of statements that occur in a test of either relativity or classical mechanics cannot be independent of the choice between Newtonian and Einsteinian theory. Moreover, it is then impossible to find equations of meaning between any word in Newtonian theory and any word in general relativity, p. 116. He infers that there is no way to compare the two theories. The inference is again mistaken. As I mentioned in section 3, linguists long ago ceased using equations of meaning to explain new and unfamiliar ideas, while scientists have always emphasized the novelty of their discoveries and of the concepts used in their formulation. This does not stop them from comparing theories, however. Thus the relativist can say that the classical formulae, properly interpreted, i.e. interpreted in the relativistic manner, are successful, but not as successful as the full relativistic apparatus. He can argue like a psychiatrist who, talking to a patient who believes in demons, Newton, adopts the patient's, manner of speaking without accepting its demonic, Newtonian, implications. This does not exclude the possibility that the patient will one fine day turn around and convince him of the existence of demons. Or he may teach relativity to the classicist like a foreign language and invite him to judge its virtues from within. Having learned Spanish to perfection and having read Borges and Vargas Llosa, would you not rather write stories in Spanish than in German? There exist many other ways in which the Newtonian and the relativist can and do converse. I have explained them in papers written since 1965. 272. Some of them in direct response to Putnam's criticisms of that time. See my Philosophical Papers, Volume 1, Chapter 6, Sections 5ff. And Volume 2, Chapter 8, Section 9ff. And Appendix. This finishes my response to A, B, and C. 7. The arguments of the preceding sections were based on I, which is Putnam's version of incommensurability. But Putnam's version is not the version I introduced when examining the relation between comprehensive theories, such as Newton's mechanics and relativity or Aristotelian physics and the new mechanics of Galileo and Newton, cf. Against Method, pages 268 ff, and Philosophical Papers, Volume 1, Chapter 4, Section 5. There are two differences. First, incommensurability as understood by me is a rare event. It occurs only when the conditions of meaningfulness for the descriptive terms of one language, theory, point of view, do not permit the use of the descriptive terms of another language, theory, point of view. Mere difference of meanings does not yet lead to incommensurability in my sense. Secondly, incommensurable languages, theories, points of view, are not completely disconnected. There exists a subtle and interesting relation between their conditions of meaningfulness. In Against Method, I explained this relation in the case of Homeric common sense versus the language aimed at by the early Greek philosophers. In Philosophical Papers, Volume 1, Chapter 4, I explained it in the case of Aristotle and Newton. I should add that incommensurability is a difficulty for philosophers, not for scientists. Philosophers insist on stability of meaning throughout an argument, while scientists, being aware that speaking a language or explaining a situation means both following rules and changing them, see Section 5 of the present chapter, are experts in the art of arguing across lines which philosophers regard as insuperable boundaries of discourse. 11. Cultural pluralism or brave new monotony. In January 1985 one was invited to contribute to a debate about the role of the arts, philosophy, and the sciences in the age of postmodernism. In my reply I, a. criticized the assumption that intellectual debates have anything to do with world culture, b. pointed out that the basic phenomenon of world culture is the relentless expansion of Western views and technologies. Monotony, not variety, is the basic theme of the age. C. asserted that cultural exchange does not need shared values, a shared language or a shared philosophy. D. defended variety and cacophony wherever it raised its head, and E. gave a brief account of the development of the philosophy of science from Maxwell to Kuhn. There is no need to reproduce my reply, as all these matters are dealt with elsewhere in the present book. But I think that the following letter, which I wrote in response to a long criticism of my reply, raises new issues and may be of some interest. March 8, 85. Dear Messrs. Virginie, Shinoda, and Kessler. Thank you for your long and detailed letter and for the care you have taken to respond to my little pamphlet. Naturally, I don't agree. Let me explain why. You ask, but can you actually deny the importance of a 273. 274. Coherent structure organizing diversity? I reply that this is neither for you nor for me to decide. It is up to the people who have created the diversity and who are now living in its midst. If the nations on the African continent are content to live side by side, without any cultural or other contact, then this is what they will do, no matter how distant thinkers may view their conduct. If Americans like the inflation of goods, images, ideas, traditions, look forward to new and improved hairsprays, car models and soap operas, and use money as the ultimate measure of value, then a dissenting intellectual may of course plead with them like a preacher, but he becomes a tyrant if he tries to use more powerful means of persuasion. We, the philosophers, wrote Edmund Husserl in a remarkable essay with the title The Crisis of the European Sciences and Transcendental Phenomenology, 1936, Functionaries of Humanity. His emphasis. The quite personal responsibility of our own true being as philosophers, our interpersonal vocation, bears within itself at the same time the responsibility for the true being of humanity. You may agree with this quotation. I think it shows an astounding ignorance. What does Husserl know of the true being of the newer, a phenomenal conceit? Is there any single individual who has sufficient knowledge of all races, cultures, civilizations to be able to speak of the true being of humanity, and, of course, a sizable contempt for anybody who has and thinks along different lines? It is true that nations and groups within a society frequently establish some kind of contact, but it is not true that in doing this they create, or assume, a common meta-discourse or a common cultural bond. The connections may be temporary, ad hoc, and quite superficial. White South African leaders, Black Muslims and European terrorists all have a great fondness for the dollar, but there is little else that unites them. Even a closer connection between cultures ABC, etc. need not be organized by a coherent structure. All that is needed is that A interact with B, B with C, C with D and so on, where the mode of interaction may change from one pair to the next and even from one episode of interaction to the next. The use of Akkadian during the First Internationalism is a case in point. It was not a necessary presupposition of this civilization, it was one of its many features. It happened to be used by special groups who wrote down what they did and therefore caught the eye of scribblers working millennia after them, namely our own scholars. Not every exchange was in Akkadian, there were local contacts. 275. Using the dialects or languages of a narrow region, and even they extended only as far as the needs and the curiosity of the participants. Besides, one must not confound a culture with its written manifestations, or with the products of its artists and its thinkers. The written laws of Hammurabi had little influence on legal practice, the first uses of linear B were purely commercial, but Greek education was not based on business ideas, it was based on Homer, i.e. on oral poetry. Some later poets, Plato among them, never got entirely reconciled to having their work distributed in written form, cf. Plato, Phaedrus 21 ad ff, and the seventh letter, especially 241 bff. Today we have lots of Marxist books and lots of Marxist ideas floating around in our universities and research centers, but does this taint our culture with Marxism? I don't think so, for there is not a trace of Marxism in our soap operas and on our religious channels. Intellectuals do not yet a culture make. Of course, we may stipulate that culture equals literature plus art plus science, but then we decide the question of the cultural effects of literature and so on by fiat, not by research. I also admit that contacts occasionally became much stronger and led to cultural unities in the sense you seem to have in mind, but watch carefully how this was achieved. Most of the time the unity was imposed by force, it only rarely emerged from the wishes and the actions of the people concerned. Scientists, artists, run-of-the-mill intellectuals do not seem to object to such developments, they may even encourage them. This is why they try to infiltrate government agencies, this is why they get so upset when their products are subjected to public control, this is why they admire cultural leaders who share their ideology and their wish for power, and support them with power plays of their own. Your yearning for a new meta-discourse smells dangerously like a rehash of the machinations of Constantine the Great or of the education of the American Indians. I, on the other hand, prefer a form of life where unities arise from the fortuitous merging of temporary links and where they may decay the moment the links are no longer popular. My next point is that you seem to be unable to make up your mind about the present condition of world culture. In your editorial statement you say that there is cultural chaos without a unifying bond. But in your letter you insinuate that there might be some bond, only it is a bond you despise, money. I agree with your letter, there is increasing uniformity, not only in the so. 276. Called First World, a nice conceit, that, calling a pushy latecomer the First World, but elsewhere as well, and all the differences and pluralisms which also exist vanish by comparison. They are amusing little confusions, they will hardly disturb General Motors, or Procter and Gamble, or the Pentagon. Yet even in your letter you repeat that chaos pervades the essence of our culture. That sounds nicely abstract and philosophical, but I wonder how closely you have considered the matter. Have you compared the clientele of soap operas, or of Reverend Falwell, or of the Super Bowl with the clientele of modem art, or of the rationalism/irrationalism issue in philosophy? Do you have the numbers? The strength of commitment? Influence on the lives of the rest of us? I don't think you have. Neither have I, but even the simplest calculation shows that you cannot possibly be right. there are now about 10,000 philosophers teaching in the US and in Canada. Most of them are obedient servants of the status quo, but let us assume that 25% are creators of disorder, a vastly exaggerated estimate. Let us also assume that each chaoticist has 100 students. Most of these students will take philosophy because they have to, they will be bored to death and will be glad when the classes and the examinations are over, but let us again assume that 25% become committed followers of their chaos-creating teachers. That would make 40,000. Do you know how many millions are watching Dalazil? How many watched the Super Bowl? Do you know the number of followers of all TV preachers taken together? Do you remember how many people voted for Reagan? How many people are still supporting his policies? The order of magnitude here is tens of millions, incomparably greater than the already quite exaggerated number I have arrived at in my small calculation. Or compare the amount of money that is being used to uphold chaos with the amount of money that supports monotony. The percentages for defense and for contributions to the arts of the gross national product would give a first approximation. They show how little the arts and the humanities amount to, and the forces of chaos are only a minuscule part of them. Don't tell me that numbers don't count. Artists and researchers in the basic sciences constantly harp on numbers when trying to show how little attention they get. I use the same argument to contest your thesis of the pervasiveness of chaos. Incidentally, you should not be so modest and explain your conflation of world culture and first world culture by editorial. 277. Inexperience. Scholars with numerous honors on their heads and tons of books and articles to their credit have talked and are still talking in exactly the same way. Just read again the short quotation from Husserl which I gave above. These people speak of culture, or of man, but what they mean are they themselves and those few select creatures who can understand their papers, so, you see, you are in excellent company. I now come to my last disagreement with you. You believe in the autonomy of art, thought, and feeling over money. Again you write in a manner that sounds impressive but gives no hint of what the implications for the real world are supposed to be. In the real world an artist needs money, money for the rent, for food, colors, brushes, visits to museums, perhaps he or she has to support a mistress or a wife, a lover or a husband, occasionally even both, he or she may have children, and so on. The same is true of philosophers, dancers, movie directors, script writers, poets. All these people need and want bigger salaries and or better prices for their products. So what do you mean by autonomy? Do you mean that an artist should do without money and starve, or live in a rat hole? Do you mean that he or she should be fed and housed but without money being involved? On the basis of barter, for example? Well, that depends on the artist. If he likes to live in a shack in the countryside and keep a cow for milk, then more power to him, but, alas, this again needs money to start with. Do you mean that it would be better if there were no money around? That is an interesting dream but of no relevance to our problem, for the question is not how artists might live in a never-never land, but how they can live here and now, in 1985, in this country. And here and now money is of the essence. Money is not inherently bad, it is a means to an end. It has been put to bad uses and some people are so fascinated by it that they devote their whole lives to its accumulation. I assume that our artist is not one of these people. He would not be a worse artist if he were. Giotto quarreled a lot about money and took great care to increase his riches, and yet he was one of the greatest artists who ever lived. So, our artist will use money, but he will not revere it like a god. Who will pay him? Perhaps a rich sponsor. In this case the artist may have to adapt his art to the wishes of his patron. Now when speaking of autonomy, do you mean to say that the patron has no right to make his wishes known? Because the artist by the very fact of being an artist is above judgment by other people? That is sheer elitism. I reject it and I reject the contempt for. 278. Others it implies. I reject elitism even more emphatically where public money is involved. A person who is paid from public funds must be ready to accept public supervision. I have the uneasy feeling that when speaking in your abstract manner about autonomy, miles removed, apparently, from anything so low and filthy as money, you actually want the public to pay artists, and scientists, and great feelers, to live and work as they, the artists etc. see fit, i.e. as parasites. Academics, using the magic hood of academic freedom, have succeeded, long ago, in making parasitism respectable. Now the artists want a piece of the action. I am against parasitism, unless agreed upon by all parties, and this means that I am against academic freedom and, naturally, against any corresponding artistic autonomy. But great art, you may say, assumes the complete autonomy of the artist. Not so, as is shown by Renaissance artists who had to obey city fathers and private moneybags, and by composers such as Haydn or Mozart who wrote Gebrauchsmusik, were paid for it and yet produced some of the greatest art of your beloved first world. But today, you might continue, the situation is different. Today the public has no taste, witness the popularity of Dallas and Dynasty. Here you argue from contempt. Dallas and Dynasty are the art of the masses, true. But the masses consist of individuals, so you can either say individuals like you and me, then you are a humanitarian and will respect their choices, or you can say individuals without taste, then you are conceited bastards, and why, then, should the masses pay you? Besides, a good movie, that is, a movie that is artistic without pandering to the recondite tastes of a few sublime souls, and there are lots of such movies, shows how close the collaboration between great art and good money can be. The collaboration is not easy, few important things are, but it can be fruitful, and it was such a fruitful collaboration, and not foggy, but at bottom contemptuous, demands for autonomy that gave us the arts of the past. One more point before I take my leave. I frequently watch the discussions and the audience reactions at the Phil Donahue show. These are ordinary people, they watch TV, they go to the movies, many of them support the one or the other policy of Ronald Reagan, many are religious people, they work hard to earn an income, to bring up their children, to support their relatives. I also read authors such as Russell Baker, his autobiography, and Evelyn Keyes, her autobiography. They, too. 279. Speak about human affairs, they speak clearly, simply, and in concrete terms, they have heart, they show wisdom, understanding, they are often puzzled, they do not know, and they say so, they do not hide their puzzlement behind empty words. Now the interests of all these people and your own interests seem to be remarkably similar. You all are concerned about adverse developments. What a difference in language. Simple and personal narration on the one side, an uneasy mishmash of impersonal abstractions on the other. I know what experts are saying about this contrast. They say that social analysis is a difficult matter and that it needs a severely theoretical discourse to succeed. I reply that a theoretical discourse makes sense in the natural sciences where abstract terms are summaries of readily available results, but that theoretical statements about social affairs often lack content and become either nonsensical or trivially false when the content is provided. Cf. my brief comments on your main thesis and on your plea for artistic autonomy. The wall of incomprehension erected by such talk is therefore not based on knowledge, it is based on pretense and on the wish to intimidate. One more reason to take a very critical look at the many privileges intellectuals have managed to steal in our society. And now all the best to you and all your further enterprises. 12. Farewell to Reason. The German version of this essay was based on the third German edition of Against Method, AM for short, which differs from the English, the French, the Japanese and the Portuguese editions and was published in 1986. Erkenntnis für freie Menschen, EFM for short, is the largely, two-thirds, rewritten German edition of Science in a Free Society, SFS. It does not contain the chapters on Kuhn, Aristotle, and Copernicus and the replies to critics which constituted more than half of the English text. Instead there is a more detailed explanation of the relation between reason and practice, an extended chapter on relativism and a sketch of the rise of rationalism in antiquity. The criticisms on which I comment were published in H. P. Dewar, ed. Versuchungen, 2 vols, Frankfurt 1980/81. 1 survey. This chapter deals with the following topics: the structure of scientific reasoning and the role of a philosophy of science, the authority of science compared with other forms of life, the importance of such other forms of life, the role of abstract thought, philosophy, religion, metaphysics, and abstract ideals, humanitarianism, for example. It also contains replies to critical essays that appeared in German in 1980 and clarifies points made in AM and EFM. 280. 281. 2. The structure of science. My main thesis on this point is, the events and results that constitute the sciences have no common structure. There are no elements that occur in every scientific investigation but are missing elsewhere. The objection that without such elements the word science has no meaning assumes a theory of meaning that has been criticized, with excellent arguments, by Ockham, Berkeley, and Wittgenstein. Concrete developments, such as the overthrow of steady-state cosmologies or the discovery of the structure of DNA, have of course quite distinct features, and we can often explain why and how these features led to success. But not every discovery can be accounted for in the same manner, and procedures that paid off in the past may create havoc when imposed on the future. Successful research does not obey general standards, it relies now on one trick, now on another, and the moves that advance it are not always known to the movers. A theory of science that devises standards and structural elements of all scientific activities and authorizes them by reference to some rationality theory may impress outsiders, but it is much too crude an instrument for the people on the spot, that is, for scientists facing some concrete research problem. The most we can do for them from afar is to enumerate rules of thumb, give historical examples, present case studies containing diverging procedures, demonstrate the inherent complexity of research, and so prepare them for the morass they are about to enter. Listening to our tale, scientists will get a feeling for the richness of the historical process they want to transform. They will be encouraged to leave behind childish things such as logical rules and epistemological principles and to start thinking in more complex ways, and this is all we can do because of the nature of the material. A theory of knowledge that intends to do more loses touch with reality. Not only are its rules not used by scientists, they cannot possibly be used in all circumstances, just as it is impossible to climb Mount Everest using the steps of classical ballet. The ideas just presented, and illustrated with historical examples in AM and in my philosophical papers, Cambridge 1981, are not new. As I wrote in section 4 of chapter 6, we find them in philosophers like Mill, his On Liberty, the outstanding presentation of a libertarian epistemology, in scientists such as Boltzmann, Mach, Duhem, Einstein, and Bohr, and then, in a 282. Philosophically already quite desiccated way, in Wittgenstein. They were fruitful ideas, the revolutions of modern physics, relativity, and quantum mechanics, and the later changes in psychology, biology, biochemistry, and high-energy physics would have been impossible without them. Yet they had only a slight impact on philosophy. Even the most iconoclastic philosophical movement of the time, neopositivism, still clung to the ancient idea that philosophy must provide general standards for knowledge and action, and that science and poetics can only profit from adopting such standards. Surrounded by revolutionary discoveries in the sciences, interesting points of view in the arts, and unforeseen developments in politics, the stem fathers of the Vienna Circle withdrew to a narrow and badly constructed bastion. The connection with history was dissolved, the close collaboration between scientific thought and philosophical speculation came to an end, terminology alien to the sciences and problems without scientific relevance took over. Fleck, Polanyi, and then Kuhn were, after a long time, the first thinkers to compare the resulting school philosophy with its alleged object, science, and to show its illusionary character. This did not improve matters. Philosophers did not return to history. They did not abandon the logical charades that are their trademark. They enriched these charades by further empty gestures, most of them taken from Kuhn, paradigm, crisis, revolution, and so on, without regard for context, and thus complicated their doctrine, but they did not bring it closer to reality. Pre-Kuhnian positivism was infantile, but relatively clear. This includes Popper, who is just a tiny puff of hot air in the positivistic teacup. Post-Kuhnian positivism has remained infantile, but it is also very unclear. Imre Lakatos was the only philosopher of science to take up Kuhn's challenge. He fought Kuhn on his own ground and with his own weapons. He admitted that positivism, verificationism, falsificationism, neither enughtens scientists nor aids them in their research. However, he denied that stepping closer to history forces us to relativize all standards. This may be the reaction of a confused rationalist who for the first time faces history in its full splendor, but, so Lakatos said, a more thorough study of the same material shows that scientific processes share a structure and obey general miles. We can have a theory of science and, more generally, a theory of rationality because thought enters history in a lawful way. 283. In AM as well as in Chapter 10 of Volume 2 of my philosophical papers I tried to refute that thesis. My procedure was partly abstract, consisting in a criticism of Lakatos' interpretation of history, and partly historical. Some critics deny that the historical examples support my case. Their objections will be dealt with below. However, if I am correct, and I am pretty sure I am, then it is necessary to return to the position of Mach, Einstein, and Bohr. A theory of science is then impossible. All we have is the process of research and, side by side with it, all sorts of rules of thumb which may aid us in our attempt to further the process but which may also lead us astray. What are the criteria that inform us that we have been misguided? They are criteria which seem to fit the situation at hand. How do we determine fitness? We constitute it by the research we do. Criteria do not merely judge events and processes, they are often constituted by them, and they must be introduced in this manner or else research could never get started. AM 26. This is my simple answer to various critics who either chastise me for opposing theories of science and yet developing a theory myself, or take me to task for failing to give a positive determination of what good science consists in. If a collection of rules of thumb is called a theory, well, then of course I have a theory, but it differs considerably from the antiseptic dream castles of Kant and Hegel and from Kamap's and Popper's dog huts. Mach, Einstein, and Wittgenstein, on the other hand, lack a more impressive edifice of thought not because they are lacking in speculative power, but because they have realized that freezing this power into a system would mean the end of the sciences, the arts, religion, and so on. And the natural sciences, especially physics and astronomy, enter the argument not because I am fascinated by them, as some confused champions of the humanities remarked, but because they are the issue. They were the weapons which the positivists and their anxious foes, the critical rationalists, trained on unloved philosophies, and they are the weapons which now cause their own demise instead. Nor do I speak of progress because I believe in it or pretend to know what it means. Using a reductio ad absurdum does not commit the arguer to accepting the premises, cf. AM, p. 27. As for the slogan "anything goes," which certain critics have attributed to me and then attacked, the slogan is not mine and it was not meant to summarize the case studies of AM and SFS. I am not looking. 284. For new theories of science, I am asking if the search for such theories is a reasonable undertaking, and I conclude that it is not. The knowledge we need to understand and to advance the sciences does not come from theories, it comes from participation. The examples, accordingly, are not details that can and should be omitted once the real account is given, they are the real account. The critics, holding a belief I explicitly reject, that there can be a theory of science and of knowledge, read only part of my story and they read it in a way that is contradicted by the rest. Small wonder they are baffled by the result. Similar remarks apply to readers who accept the slogan and interpret it as making research easier and success more accessible. My objection to these lazy anarchists is again that they misread my intentions. Anything goes is not a principle I defend, it is a principle forced upon a rationalist who loves principles but who also takes history seriously. Besides, and more importantly, an absence of objective standards does not mean less work, it means that scientists have to check all ingredients of their trade and not only those which philosophers and establishment scientists regard as characteristically scientific. Scientists can thus no longer say, we already have the correct methods and standards of research, all we need to do is to apply them. For according to the view of science that was defended by Mach, Boltzmann, Einstein, and Bohr, and which I restated in AM, scientists are not only responsible for the correct application of standards they have imported from elsewhere, they are responsible for the standards themselves. Not even the laws of logic are exempt from their scrutiny, for circumstances may force them to change logic as well. Some such circumstances have arisen in the quantum theory. This situation must be kept in mind when considering the relation between great thinkers on the one hand and editors, moneybags and scientific institutions on the other. According to the traditional account, scientists with uncommon ideas and the institutions from which they seek support have certain general ideas in common. They are both rational. All a scientist in search of money has to do is to show that his research, apart from containing novel suggestions, conforms to these ideas. According to the account defended by me, the scientists and their judges must first establish some common ground. They can no longer rely on standard slogans. Their exchange is free, not guided, CFSFSP.29. In such a situation the demand of anarchic scientists for 285 greater freedom can be interpreted in two ways. It can be interpreted as a demand for an open exchange that seeks understanding without being tied to specific rules. But it can also be interpreted as a demand for acceptance without examination. In the terms of AM and SFS, the latter demand might even be supported by pointing out that ideas that were once regarded as absurd have subsequently led to progress. The argument overlooks that the judges, editors, or moneybags can use the same reasons. The status quo, too, has led to progress, and anything goes includes the methods of its defenders. It is therefore necessary to offer a little more than arrogance and vague generalities. The case studies show that scientific rebels took this extra step. Galileo, for example, did not just complain, he tried to convince his opponents with the best means at his disposal. These means frequently differed from standard professional procedures, they even conflicted with common sense. Here is the anarchic component of Galileo's research, but they had a reason of their own which could be expressed in common sense terms, and they were occasionally successful. And let us not forget that a full democratization of science will make life even more difficult for the self-proclaimed discoverers of great ideas, who will then have to address people who do not even share their interest in science or research. What will our freedom-loving anarchists do under such circumstances? When their opponents are no longer hated big shots but much beloved free citizens. 3 case studies. In this section I shall deal mainly with objections to my treatment of Galileo. Let me repeat that I criticize not Galileo's procedures, which are excellent examples of the inventiveness of scientific practice mentioned in section 2, but those philosophical theories which, if applied with a better knowledge of history, would have to reject them as irrational. Galileo was irrational in terms of these theories, but he was also one of the greatest scientist philosophers who ever lived. According to Gunnar Andersson, the Galileo case may endanger an overly simple and naive version of falsificationism, but it does not threaten a philosophy where both theories and observations are fallible. My interpretation of Galileo's assumptions. 286. Further reveals, according to Andersson, that I have not understood Popper's definition of ad hoc hypotheses. Ad hoc hypotheses, says Andersson, are not merely introduced to explain special effects, they also lower the degree of falsification of the system in which they occur. Now that is precisely what Galileo's assumptions do. Galileo's account of motion turns the tower argument from a refutation of Copernicus into a confirming instance and reduces the content of the Aristotelian dynamics that preceded it, A.M., pages 99f. This latter theory, explained in books I, II, VI, and 8 of the Physics, deals in a general way with a variety of changes including locomotion, generation, corruption, qualitative change, such as the transmission of knowledge from a well-informed teacher to an ignorant pupil, an example often used by Aristotle, increase and decrease. It contains theorems such as, every motion is preceded by another motion, there exists a hierarchy of motions which starts from an unmoved cause of motion, is followed by a primary motion with constant, angular, velocity and branches out from there. The length of a moving object has no precise value, ascribing to an object a precise length means assuming that it is at rest, and so on. The first theorem was proved by assuming that the world is a lawful entity. The proof can be used today against the Big Bang theory of the origin of the universe or against Wigner's idea that the reduction of the wave packet is due to an act of consciousness. The last theorem, which is based on Aristotle's account of continuity, anticipates basic ideas of the quantum theory, cf. Chapter 8 for details. Aristotle's theory of motion is coherent and it was confirmed to a high degree. It stimulated research in physics, electricity, cf. J. L. Heilbronn, Electricity in the 17th and 18th Centuries, University of California Press 1979, Physiology, Biology and Epidemiology down to the late 19th century, and it remains relevant today. The mechanical views of the 17th and 18th centuries and their modem sequels are incapable of dealing even with their own prize process, locomotion, cf. the work of Bohm and Prigogine as well as Chapter 8 of the present book. What did Galileo do? He replaced this complex and sophisticated theory, which already contained the distinction between laws of inertia, they describe what happens when no forces are acting, and laws of forces, they describe how forces influence motion, by his own law of inertia which lacked corroboration, applied to locomotion only and drastically reduced the degree of falsification of the entire system. Concerning the falsifiability of observational statements, the situation is, however, as follows. Critical rationalism, the philosophy defended by Anderson, is either a fruitful point of view that guides scientists, or it is empty talk that can be reconciled with any procedure. Popperians say it is the first, rejection of Newerth's assertion that any statement can be crossed out for any reason whatsoever. This is why they insist that basic statements intended to refute a theory must be highly corroborated. Galileo's telescopic observations did not satisfy this demand, they were self-contradictory, not everybody could repeat them, those who did repeat them, Kepler, got puzzling results, and there existed no theory to separate phantoms from veridical phenomena. Physical optics, mentioned by Anderson, is irrelevant. The basic statements under discussion are not about rays of light but about the position, color, and structure of visual patches, and a popular hypothesis correlating the first with the second could be easily shown to be false, cf. A.M., p. 137. Galileo's basic statements are therefore bold hypotheses without much corroboration. Anderson accepts this description. It needs time, he says, to obtain the corroborating evidence, and the related touchstone theories, to use an excellent expression of Lacadoz's. The first interpretation of critical rationalism mentioned above asserts that during the search the statements have no refuting power. If one still says, as Anderson does, that Galileo refuted popular views by his observations, then one moves from the first interpretation to the second, where basic statements can be used in any way whatsoever. The verbiage remains critical, but its content has evaporated. Next comes a criticism which T.A. Whittaker has published in 2 letters in the journal Science, May 2 and October 10, 1980. Whittaker points out that there exist 2 sets of pictures of the moon, the woodcuts, which I presented in AM, and the copper plates which are more accurate, from a modem point of view. The copper plates, says Whittaker, show Galileo to be a better observer of the moon than I make him out to be. Now, first of all, I never doubted Galileo's ability as an observer. Quoting R. Wolf, who writes that Galileo was not a great astronomical observer, or else the excitement of the many telescopic observations made by him at the time had temporarily blurred his skill or his critical sense. I reply, AM, p. 129, that this assertion may well be true, though I rather doubt it in view of the extraordinary observational skill which Galileo exhibits on other occasions. But it is poor in content and, I submit, not very interesting. There are however other hypotheses which lead to new suggestions and which show us how complex the situation was at the time of Galileo. I then mention two such hypotheses, one dealing with general features of contemporary telescopic vision, the other considering the assumption that perceptions, i.e. the things seen with the naked eye, have a history, which may be discovered by combining the history of visual astronomy with the history of painting, poetry, etc. Secondly, reference to the copper plates does not remove all the troublesome aspects of Galileo's observations of the moon. Galileo not only drew pictures, he also gave verbal descriptions. For example, he asked, CFAM, p. 127, why don't we see unevenness, roughness, and waviness in the waxing moon's outmost periphery which faces west, in the waning moon's other circular edge which faces east, and in the full moon's entire circumference? Why do they appear perfectly round and circular? Kepler replied, on the basis of naked eye observations, cf. AM, p. 127 fn 24. If you look carefully at the moon when it is full, it seems perceptibly to be lacking in roundness, and he answered Galileo's question by saying, I do not know how carefully you have thought about this subject or whether your query, as is more likely, is based on popular impression. 4. I stated that there was surely some imperfection in this outermost circle during full moon. Study the matter again and tell us how it looks to you. This little exchange shows, thirdly, that the problems of observation which existed at Galileo's time cannot be solved by showing that Galileo's observations agree with our view of the matter. To see how Galileo proceeded, if he was rational or if he broke important rules of scientific method, we have to compare his achievements and his suggestions with his surroundings and not with the situation in an as yet unknown future. If it turns out that the phenomena reported by Galileo were not confirmed by anyone else, and that there were no reasons for 289. Trusting the telescope as an instrument of research, but many reasons, both theoretical and observational, that spoke against it, then it was as unscientific for Galileo to push the phenomena as it would be unscientific for us to push experimental results which lack independent corroboration and are obtained by doubtful methods, no matter how closely his observations approach our own. For to be scientific in the sense that is at issue here, and that is criticized in AM and SFS, means to act properly with respect to existing and not with respect to possible knowledge. Now I use the woodcuts in order to gauge the reactions of Galileo's contemporaries. Note again that I did not try to argue that Galileo was a lousy scientist because the woodcuts differ from modern pictures of the moon. Such an argument would have conflicted with the considerations just given. My assumption was, rather, that the moon as seen with the naked eye looks different from the woodcuts, that it might have looked different to Galileo's contemporaries, and that some of them might have criticized the Sidereus Nuncius on the basis of their own naked eye observations. This assumption is still useful, for the woodcuts accompanied most editions of the book. Does it apply to the engravings as well? It does, as is shown by Kepler's criticism. There were, moreover, many reasons why the telescope was not uniformly regarded as a reliable producer of facts. Some of these reasons, both empirical and theoretical, are assembled in A.M. Whittaker's assertion, made in his second communication, that Galileo's drawings of the moon are of a high quality when compared with modem pictures has no bearing on this discussion. John Worrell ascribes to me the truism that theoretical facts are dependent on theory as well as arguments that depend on taking fact at a very high theoretical level. What I actually assert in the paper in which these matters are explained, now reprinted as Chapter 2 of Volume 1 of my philosophical papers, is that all facts are theoretical, or, in the formal mode of speech, logically speaking all terms are theoretical, OPCIT, p. 32, fn 22, and not merely iterary laden. I also argue for this assertion and show that and why it is preferable to alternatives, including the alternative Worrell seems to have in mind. Worrell's complaints nowhere touch this position and these arguments. John Worrell's difficulties show how little Popperians have advanced beyond more naive forms of empiricism. Worrell wants 290. To distinguish empirical facts and theoretical facts, but he does not know how to proceed. Occasionally he proceeds psychologically, i.e. he distinguishes between facts that are accepted by all experts in a certain domain and more doubtful facts which give rise to debates. This came up, in Testability and Meaning, and I, in section 2 of the above-mentioned paper, had done before him, and in a much clearer way. On other occasions he seems to assume that agreements reached go beyond psychology and are grounded in the facts themselves. Empirical facts are less pervaded by theory than theoretical facts, they have an empirical core. Neurath, Kamap, and I would say that such facts appear to be less pervaded with theory. The old Greeks perceived their gods directly, the phenomena did not contain any theoretical element, but philologists eventually discovered the complex ideology at their basis and showed how even very simple divine facts were constituted by a highly complex structure. A.M. Ch. 17. Classical physicists described and we still describe our surroundings in a language which neglects the relation between observer and observed object. We assume stable and unchanging things, we base our experiments upon them, but the theory of relativity and the quantum theory showed that this language, this mode of perception and this manner of carrying out experiments rested on cosmological assumptions. The assumptions were not explicitly formulated. This is why we don't notice them and simply speak of empirical facts, but they underlie all phenomena. The apparently empirical facts are theoretical through and through. Yet they frequently function as judges between alternative views. Worrell assumes that judges must be neutral, hence the need for a solid empirical core, i.e. he assumes that scientists who use facts when examining a variety of theories do not change them in the course of the examination. The assumption can easily be shown to be wrong. Relativists and ether theoreticians have different facts, even in the domain of observation. For the relativist, observed masses, lengths, or time intervals are projections of four-dimensional structures into certain reference systems, cf. Singh in DeWitt and DeWitt, Relativity, Groups, and Topology, New York 1964, while the absolutists regard them as inherent properties of physical objects. Relativists admit that classical descriptions, which were designed to express classical facts, may occasionally be used to convey information about relativistic facts and they employ them in the relevant circumstances. But this does not mean that they accept their classical interpretation. 291. On the contrary, their attitude is very close to that of a psychiatrist who talks to a patient claiming to be possessed in his, the patient's, language, without accepting an ontology of devils, angels, demons, and so on. Our ordinary ways of speaking, scientific arguments included, are much more elastic than is imagined by Worrell. The tower argument, according to Worrell, was diffused by Galileo in the following way: the moving earth taken in conjunction with the Aristotelian theory of motion, according to which an object not under the influence of forces comes to rest, increases the distance between the stone and the tower. The stone does not move away from the tower. Therefore, says Worrell's Galileo, the experiment does not refute Copernicus, but a more complex theoretical system, and he replaces Aristotle's dynamics, which is part of the system, by his own law of inertia. Here he remains within the framework of Duhem's analysis of theory change. More especially, he corrects a logical error of the anti-Copernicans according to whom the false statement, the stone moves away from the tower, follows directly from the assumption that the earth rotates. So far John Worrell. Now first of all, the alleged logical error was never committed by the anti-Copernicans. Being good Aristotelian logicians, they knew very well that the derivation needed at least two premises. They even mentioned them explicitly, but they directed the arrow of falsification against only one premise, the motion of the earth, as the other was theoretically plausible and confirmed to a high degree and, besides, it was not the topic at issue. Cf. Popper's comments on Duhem's argument against simple falsifiability. Secondly, the replacement of Aristotle's law of inertia was only part of the change carried out by Galileo. The Aristotelian law described absolute motions, and so did the tower argument. The predicted deviation of the stone from the tower is of course a relative change, but the problem under debate here is what Galileo changed and not what reasons he used when carrying out the change. If a new auxiliary hypothesis is introduced, then this hypothesis, too, must use absolute motions. It must be a form of the impetus theory. But Galileo gradually became a kinematic relativist, AM, p. 78 FN 10, p. 96, FN 15. His auxiliary hypothesis had to work without impetus. Thus he did not merely change one hypothesis of an otherwise unchanged conceptual system, absolute motion around the Earth, or around the Sun, but not straight towards the center. He also replaced the concepts of the system. He introduced a new worldview, which 292 had been prepared by others. The first process can be explained by Duhem's scheme, the second cannot. Worrell also criticizes the way in which I use Brownian motion to argue for a plurality of theories. This criticism is such a wonderful example of the shortcomings of a purely philosophical approach, as described by me in Volume 2, Chapter 5 of my philosophical papers, that it deserves our fullest attention. In Chapter 3 of AM, I showed that Brownian motion contradicts the second law of phenomenological thermodynamics only when analyzed by the kinetic theory, which also contradicts that law. Worrell says he does not understand my argument. So far so good. There are many things which many people do not understand. In order to understand the argument, Worrell translates it into a language he is familiar with, a kind of pigeon logic. This, too, is unobjectionable. If I don't understand an argument, then I shall try to reformulate it in my own way. Worrell goes further. He complains that I did not formulate my argument in his language in the first place. But my argument was not part of a personal letter to him. It was addressed to physicists favoring a theoretical monism, and they seem to understand it perfectly. Besides, Worrell does not just object to having been left out, he assumes that the language he understands is the only reasonable language there is. In this he is certainly mistaken, as is shown by the nonsense his translation produces. His notion of evidence, for example, makes it impossible to speak of unknown evidence or of events which, although well known, and although evidence, are not known to be evidence. Like a native speaker of a language too poor to express certain states of affairs, he projects the lacuna onto my argument and claims to have shown its incoherence. I, on the other hand, would conclude that there are better languages than pigeon logic. Using one such language, my argument can be stated as follows. Assume we have a theory T, and by this I mean the entire complex, theory plus initial conditions plus auxiliary hypotheses and so on. T says that C will occur. C does not occur, C occurs instead. If this fact were known, then one could say that T was refuted and C would be the refuting evidence. Note that I do not distinguish between facts and statements. No step in the argument depends on the distinction, and no intelligent person will be confused by its absence. Assume further that there are laws of nature which prevent us from directly separating C and C. There exists no experiment that could tell us the difference. Finally, let us assume that it is possible to identify C in a roundabout 293 manner, with the help of special effects which occur in the presence of C, but not in the presence of C, and which are postulated by an alternative theory T. An example of such an effect would be that C triggers a macro process M. Worrell has difficulties with triggers. Any dictionary will tell him what the word means. In this case, T gives us evidence against T that could not have been discovered by using T and the associated experiments only. For God, M or C are evidence against T. We humans, however, need T to ascertain that fact. Brownian motion is a special case of the situation I have just described. C are the processes in an undisturbed medium in thermal equilibrium according to the phenomenological theory of thermodynamics. C are the processes in such a medium according to the kinetic theory. C and C cannot be experimentally distinguished because any instrument for the measurement of heat contains the very same fluctuations it is supposed to reveal in our special case. M is the motion of the Brownian particle, T the kinetic theory. As in the Galilean case, we can press these elements into the Duhamian scheme by saying that one auxiliary hypothesis was replaced by another auxiliary hypothesis and that some difficulty was removed thereby. Note, however, that in our case it was not the difficulty that led to the replacement but the replacement that helped us find the difficulty, and this feature disappears in Worrell's analysis. Turning to more general objections, I wholeheartedly agree with Ian Hacking that the sciences are more complex and many-sided than I assumed in some of my earlier writings and also in parts of AM. I had simplistic ideas both about the elements of science and about their relations. Science does contain theories, but theories are neither its only ingredients nor can they be adequately analyzed in terms of statements or other logical entities. We may admit that there exist axiomatic formulations and that some scientific ideas have been defined in a precise way. We may also admit that scientists when doing research occasionally rely on the results of these efforts. However, they use them in a rather loose way, combining axioms from different domains in a manner usable to give a heart attack to philosophers entranced by simple forms of logic. Logic itself has now entered a stage where formalizations are used in a freewheeling way and where anthropological considerations, finitism, play an important role. Altogether the scientific enterprise seems to be much closer to the arts than older logicians and philosophers of science, myself. 294. Among them, once thought, for this side of the matter cf. my essay Wissenschaft als Kunst, Frankfurt 1984. My first doubts about the identification of science with the explicit features of its theories and its observational reports arose in 1950 when I read a manuscript copy of Wittgenstein's Philosophical Investigations. I still express these doubts abstractly, in terms of conceptual problems, incommensurability, subjective elements of the theory of explanation. Starting work on Chapter 17 of AM, I was then led to question the adequacy of abstract procedures both in the sciences and in the philosophy of science. Here I learned from 3 books, Bruno Snell's magnificent Discovery of the Mind, recommended to me by Barbara Feyerabend, Heinrich Schaeffer's Principles of Egyptian Art, a book of importance far beyond the subject matter treated, and Vasco Ronchi's Optics, the Science of Vision. Today I would add Panofsky's writings on the history of the arts, especially his path-breaking essay Die Perspektive als Symbolisk Form, and Alois Riegel's Stromische Kunstindustrie where the doctrine of artistic relativism is explained simply, and with powerful arguments. All I had to do to extend these arguments to the sciences was to realize that scientists, too, produce works of art, the difference being that their material is thought, not paint, nor marble, nor metal, nor melodious sound. Regarding thought itself, I started my escape from positivism by distinguishing between 2 different kinds of traditions which I called abstract traditions and historical traditions respectively, details in Ch1, Volume 2 of my philosophical papers, and in Wissenschaft als Kunst, as well as in Chapter 3 of the present book. There are many ways of characterizing these traditions. One difference which I found a most helpful starting point is the way in which the 2 traditions deal with their objects, people, ideas, gods, matter, the universe, societies, and so on. Abstract traditions formulate statements. The statements are subjected to certain rules, rules of logic, rules of testing, rules of argument, and so on, and events affect the statements only in accordance with the rules. This, it is said, guarantees the objectivity of the information conveyed by the statements, or of the knowledge they contain. It is possible to understand, criticize, or improve the statements without having met a single one of the objects described. Examples: elementary particle physics, behavioral psychology, molecular biology, which can be run by people who never in their life saw a dog, or a prostitute. Members of historical traditions also use statements, but they 295 talk in a very different way. They assume, as it were, that the objects already have a language of their own and they try to learn this language. They try to learn it not on the basis of linguistic theories but by immersion, just as small children familiarize themselves with the world. And they try to learn the language of the objects as they are, and not as they appear after they have been subjected to standardizing procedures, experiments, mathematization. Categories of the abstract approach such as the concept of an objective truth cannot describe a process of this kind which depends on the idiosyncrasies of both objects and observers. It makes no sense to speak of the objective existence of a smile which, depending on context, can be seen as a kind smile, a cruel smile, or a bored smile. Abstract and historical traditions have fought each other from the beginning of Western thought. Their contest started with the ancient battle between philosophy and poetry, Plato, Republic 607b, see chapter 3 of the present book. It continued in medicine where the theoretical approach of Empedocles and the element physicians was criticized by the author of Ancient Medicine, details in chapter 1, section 6, and in chapter 6, section 1. The antagonism characterized Thucydides' criticism of Herodotus and it has survived until today in psychology, behaviorism versus first-hand methods, biology, molecular biology versus qualitative types of biological research, medicine, scientific medicine versus healers of all sorts, ecology, and even mathematics, Kantorianism versus constructivism, to use terms first suggested by Poincare. Abstract traditions change into historical traditions during times of crisis and revolution, which supports my thesis that good sciences are arts, or humanities, not sciences in the textbook sense. Ian Hacking's analysis of experimental procedures is an excellent illustration of the art aspect of scientific research. Alan Musgrave shows that the instrumentalistic tradition in ancient astronomy was much weaker than Duhem thought. He forgot to mention that modern scientific realism uses an instrumentalism of qualitites and qualitative laws. Realists take it for granted that qualities which do not enter the body of science but which enable us to contribute to it will not lead us astray. Modern science, which created but never solved the mind-body problem, uses instrumentalism at its very basis, and it shows, for instance, in the quantum theory of measurement. In a short introduction, which has nothing to do with the bulk of his paper and which he seems to have added as an afterthought, Musgrave produces a 296 curious criticism of an earlier essay of mine, reprinted in Philosophical Papers Volume 1, Chapter 11. There I argued that most philosophical reasons for realism are too weak to overcome the physical reasons against it, and that they must be made stronger, and I then developed the needed stronger reasons. According to Musgrave I did the very opposite. I tried to find universal arguments for instrumentalism. I don't think that Alan misread what I had written, for he is a careful critic and the paper he criticizes one of the clearest papers I have written, but I am quite ready to accept a plea of temporary insanity. Let me add, incidentally, that I no longer believe in the relevance, for our understanding of the sciences, of general arguments such as those produced in my paper. I agree with practically all the points and objections made in Grover Maxwell's beautiful essay on the mind-body problem. I admit that despite good intentions I too often relapsed into the empiricist practice of treating meaning in an a priori manner, but I had my sane moments, too, and then I treated meanings as neurophysiological structures or programs. See Philosophical Papers Volume 1, Chapter 6, Volume 2, Chapter 9. I also admit that I occasionally forgot the contingent nature of the pragmatic theory of observation. For my sane moments on this point cf my little note Science Without Experience, Philosophical Papers, Volume 1, Chapter 7, which made Ayn Rand curse me in an open letter to all American philosophers. It is true that in criticizing acquaintance I set up a straw man. Actually, the straw man, straw woman, was set up not by me but by the sense datists, but having removed her, it, him. I thought I had removed all aspects of acquaintance, and in this I was certainly mistaken. I was not consistent in my mistake for I occasionally assumed, as Russell had done, that the brain could be directly perceived, but I did not draw the correct conclusion and declare some physical events to be mental. I am not too upset by the fact that some of my arguments may provide ammunition for the eliminative ment ost. This, I think, appeals to all arguments about contingent matters. Grover's own theory, on the other hand, seems to me to rely too heavily on scientific notions and procedures. Grover's assertion that science works does not remove my uneasiness. Science works sometimes, it often fails, and many success stories are rumors, not facts. Besides, the efficiency of science is determined by criteria that belong to the scientific tradition and thus cannot be regarded as objective judges. For example, science does not save souls. I conclude that Grover 297 has shown how our notions of mind and body can be developed within the scientific framework without thereby removing ideas that come from different traditions, the tradition of the Dogon, or the Azanda, or of Ecuadorian peasants. And I am very glad that he has not succeeded in doing the latter. At least there is now a chance of meeting him again, on a different plane, in different circumstances, but, hopefully, with his caustic humor unchanged. For science, one tradition among many. The second topic of my writings is the authority of the sciences. I assert that there exist no objective reasons for preferring science and Western rationalism to other traditions. Indeed, it is difficult to imagine what such reasons might be. Are they reasons that would convince a person, or the members of a culture, no matter what their customs, their beliefs, or their social situation? Then what we know about culture shows us that there are no objective reasons in this sense. Are they reasons which convince a person who has been properly prepared? Then all cultures have objective reasons in their favor. Are they reasons referring to results whose importance can be seen at a glance? Then again all cultures have at least some objective reasons in their favor. Are they reasons which do not depend on subjective elements such as commitment or personal preference? Then objective reasons simply do not exist. The choice of objectivity as a measure is itself a personal and/or group choice, or else people simply accept it without much thought. It is true that Western science has now infected the whole world like a contagious disease, and that many people take its intellectual and material products for granted, but the question is, was this a result of argument, in the sense of the defenders of Western science, i.e. was every step of the advance covered by reasons that are in agreement with the principles of Western rationalism? Did the infection improve the lives of those who were touched by it? The answer is no to both questions. Western civilization was either imposed by force, not because of arguments showing its intrinsic truthfulness, or accepted because it produced better weapons, see Chapter 1, Section 9, and its advance, while doing some good, also caused enormous damage. For a survey consult J. H. Bodley, Victims of Progress, Menlo Park, California 1982. It not only destroyed spiritual values, 298, which gave meaning to human youths, it also damaged a corresponding mastery of the material surroundings without replacing it by methods of comparable efficiency. Primitive tribes knew how to deal with natural disasters such as plagues, floods, droughts. They had an immune system that enabled them to overcome a great variety of threats to the social organism. In normal periods they exploited their environment without damaging it, using knowledge of the properties of plants, animals, climatic changes, and ecological interactions which we are only slowly recovering. Details and ample literature are given in Levi Strauss, The Savage Mind, and later more detailed studies of a similar kind. This knowledge was severely damaged and partly destroyed, first by the gangsters of colonialism and then by the humanitarians of developmental aid. The resulting helplessness of large parts of the so-called Third World is the result of, not a reason for, outside interference. Majid Rahnima, an Iranian scholar, has compared the effects of developmental aid with the effects of the illness AIDS, which destroys the immune system of the human body. From Aid to AIDS, unpublished manuscript, Stanford 1984. He has also commented on the way in which knowledge was turned from a common good to a rare and inaccessible commodity. Cultures and civilizations, He writes Education for Exclusion or Participation, manuscript, Stanford, April 16, 1985. Were formed, enriched, and transmitted by millions of people who were learning by living and doing, for whom living and learning was synonymous, as they had to learn for living and they learned whatever was meaningful to them and to the community they belonged to. Before the present school system came into being, for thousands of years, education was not a scarce commodity. It was not a product of some institutional factories, the possession of which could bestow upon a person the right to be called educated. The new school system served as a rather efficient channel of sieving out, into the power establishment, the most ambitious, and sometimes the brightest, aiming at personal and professional fame. It also, paradoxically, did serve as a culture medium to some outstanding individuals, among them radical thinkers and revolutionaries who used some of its unique learning resources for their own liberating purposes. Yet, on the whole, it soon became an infernal machine which distinguished itself in the systematic organization of excluding processes against the poorest and the powerless. The old days, when every adult was a teacher, were over. Now, only those certified by the school system, according to its self-devised criteria, could have the right to teach. Education thus became a scarcity. My emphasis. 299. It is interesting to see how little influence these discoveries have had on the sermons preached by professional rationalists. Karl Popper, for example, bemoans the general anti-rationalist atmosphere of our time, praises Newton and Einstein as great benefactors of humanity, but breathes not a single word about the crimes committed in the name of reason and civilization. On the contrary, he seems to think that the benefits of civilization may occasionally have to be imposed on unwilling victims by a form of imperialism. See Chapter 6, Section 1. There are various reasons why so many intellectuals still argue in this short-sighted way. One reason is ignorance. Most intellectuals have not the foggiest idea about the positive achievements of life outside Western civilization. What we had, and, unfortunately, still have, in this area are rumors about the excellence of science and the dismal quality of everything else. Another reason lies in the immunizing moves rationalists have devised to overcome difficulties. For example, they distinguish between basic science and its applications. If any destroying was done, then this was the work of the appliers, not of the good and innocent theoreticians. But the theoreticians are not that innocent. They are recommending analysis over and above understanding, and this even in domains dealing with human beings. They extol the rationality and objectivity of science without realizing that a procedure whose main aim it is to get rid of all human elements is bound to lead to inhuman actions. Or they distinguish between the good which science can do in principle and the bad things it actually does. That can hardly give us comfort. All religions are good in principle, but unfortunately this abstract good has only rarely prevented their practitioners from behaving like bastards. Thoughtless people are in the habit of pointing out that every reasonable person will be persuaded that science knows best. The comment admits a weakness of argumentation. Arguments do not work on everyone, they work only on people who have been properly prepared. And this is a general feature of all ideological debates. Arguments in favor of a certain worldview depend on assumptions which are accepted in some cultures, rejected in others, but which because of the ignorance of their defenders are thought to have universal validity. Keeks's attempt to overcome relativism is an excellent example of this situation. He makes three assumptions. 1. It is important to solve problems. 2. There exist more or less unambiguous methods for 300. Solving problems. 3. Some problems are independent of all traditions. Problems of this kind Keeks calls problems of life. Keeks also assumes that explicit conceptualization plays an important part in recognizing, formulating, and solving problems. But for the Orphics, some Christians, and some Muslim fundamentalists, many of the things a Western intellectual might call problems were not undesirable situations waiting to be removed by human ingenuity but either tests of moral fiber, cf. the function of initiation rites, or preparations for a difficult task, or necessary ingredients of a life that would cease to be human without them. Some cultures treat problems as quirks which cause amusement, not consternation. One simply lets them pass instead of trying to solve them. White government officials in Central Africa were often upset by the fact that problems they noticed and conveyed to their black colleagues were not dealt with seriously, by an increased effort of thought, but were simply laughed out of court. The bigger the problem, the greater the hilarity. This, the white rationalists said, was a very irrational way to behave, and so it was, according to their standards. On the other hand, what a fine way of avoiding wars and the misery they create. Do something certainly is not uniformly superior to let it be. Keeks articulates the procedures customary within certain traditions. He does not give us objective, i.e. trans-traditional principles. Problems of life in Keeks's sense are parts of special and relatively young traditions of a materialistic humanistic bent. Their solutions cannot be impartial judges of the rest. Moreover, even secular solutions allow for many ways of living outside the sciences, as is shown by our artists and by the wide spectrum covered by apparently objective concepts such as the concept of health, cf. Foucault. We have to admit that many values and many cultures have ceased to exist. They were killed and hardly anybody now remembers them. But this does not mean that we cannot learn from them, and, besides, Keeks wants a theoretical solution to the problem of relativism, and such a solution is not forthcoming. Similar remarks apply to Noretta Cork's interesting and provocative essay. She must be praised for emphasizing that in dealing with citizens' appearance is at least as important as reality, which at any rate is nothing but the way in which things appear to fashionable experts. Not only must justice be done, but justice must seem to be done. Well said. What counts in a democracy is the experience of the citizens, i.e. their subjectivity. 301. And not what small gangs of autistic intellectuals declare to be real. If an expert does not like the ideas of the common folk, then all he has to do is to talk to them and try to persuade them to think along different lines. In so doing, he must not forget that he is a beggar and not a teacher trying to pound some truth into the heads of penitent pupils. But her attempt to separate this experience from some reality cannot succeed. I agree that the sciences, and civilizations built around them, contain something called expert opinion, and that it differs from what experts call popular superstitions, but I would add that this is true of other traditions as well. For example, it is true of the Dogon, as Griel has shown in his marvelous book. I also agree that expert opinion occasionally shows some uniformity. All churches have temporary uniformities, but the occasional convergence in some areas are more than compensated by disagreements in others. Nor does the convergence of expert opinion establish an objective authority, and if it does, then we have many different authorities to choose from. The distinction between expert reality and layman appearance dissolves into what appears to every one of us, experts included. That rationalists clamoring for objectivity and rationality are just trying to sell a tribal creed of their own becomes very clear from the reactions of some less gifted members of the tribe. Thus Tibor Maxim, writing at the expense of an outfit ominously called the Reason Foundation, I am referring to a review of SFS which appeared in Philosophy of the Social Sciences, 1982, distinguishes between acceptable standards, ideas, and traditions that are mere caprice and destructive to human life. What is the rationale for his distinction? A theory of man. What is the gist of his theory of man? That human beings are rational animals. Biological beings with the distinctive need and capacity for principled, or conceptual, thought and action. This, of course, is a perfect description of intellectuals. The only thing missing is the craving for large salaries, but a person with a somewhat different perspective will have to point out, in all modesty, that Maxim's theory of man is but one view among many, and that intellectuals, fortunately, are still only a small percentage of humanity. There is the view that humans are misfits in the material world, unable to understand their position and their purpose, and with a distinctive need for salvation. There is the view, closely related to the one just mentioned, that humans consist of a divine spark enclosed in an earthen vessel, a trace of gold embedded in dirt, as the Gnostics 302. Were in the habit of saying, with the distinctive need for liberation by faith. And these are not just abstract and capricious views, they have been, and still are, part of the lives of millions of people. There is the view, found among Buddhists, that humans want to escape pain, that thought and purposeful action based on thought are the main causes of pain, and that pain will cease once customary distinctions are removed and customary purposes abolished. The Hopi Genesis represents humans as being originally in harmony with nature. Thought and striving, or in other words the very same need for principled thought and action which Maxim makes the center of humanity, destroy the original harmony, the animals withdraw from the human species is split into races, tribes, and small groups with different ideas, and different languages arise until even individuals no longer understand each other. But humans, having the distinctive need and capacity for harmony, can overcome the fragmentation by freeing themselves from the fetters of conceptual thought and the strife it creates and by basing their lives on love and intuitive understanding. There are numerous views of this kind and they all differ from the theory mentioned and taken for granted by Maxim. Now it is of course Maxim's good right to favor one view and condemn another. But he does so posing as a rationalist and a humanitarian. He claims to have not only anathemas but also arguments and to be motivated by a love for humanity. A look at his criticism shows that both claims are spurious. His arguments are but curses pronounced in the stiff rhetoric of the self-conscious scholar, and his love for humanity stops right at his office door, or at the cashier's desk of the Reason Foundation. As is customary among intellectuals, Maxim uses unanalyzed cases such as the Jonestown killings to frighten his readers instead of trying to enlighten them. German rationalists use Auschwitz and, more recently, terrorism ad nauseam for the same purpose. These are easy cases, says Maxim. How naive can you get? In Jonestown, some people committed suicide freely, in the full knowledge of what they were doing, case 1. Others wavered, were undecided, would have liked to survive but submitted to the pressure of their peers and their leaders, case 2. Still others were simply murdered, case 3. For Maxim the distinctions do not exist. But they are essential for an instructive analysis of the case. Case may be easy if one wants to talk in this superficial way, though there are sizable problems even here. Should one kill bodies to save souls? Rational Inquisitors. 303. Thought so, and with excellent arguments. Are these arguments to be disregarded? Are we to take materialism for granted? I have no objection to the latter step, but where does this leave a rationalist, i.e. a person who claims to have arguments for every move he makes? Case 1 is again easy, though not in the way assumed by Maxim. Of course, it is destructive to human life, but is human life an overriding value? The Christian martyrs did not think so, and neither Maxim nor any other rationalist has succeeded in showing that they were mistaken. They had a different opinion, that is all. Socrates expressed a similar sentiment before dying. He was not alone, for the same sentiment can be found in Herodotus, in Sophocles, and in other outstanding representatives of classical Greece. Not once does it occur to Maxim that his view of a human being is one among many, that he is a party to the debate and not its supervisor. There remains case 2. Here I fully agree with those who demand that people be protected from peer group and leader pressures. But this caveat applies not only to religious leaders such as the Reverend Jones but also to secular leaders such as philosophers, Nobel Prize winners, Marxists, liberals, hitmen of foundations and their educational representatives. The young must be strengthened against being imposed upon by so-called teachers, and especially against ratio-fascists like Maxim and his peers. Unfortunately, contemporary education is far from agreeing with this principle. Finally, there is the old argument that non-scientific traditions have already had their chance, that they did not survive the confrontation with science and rationalism, and that attempts to revive them are therefore both irrational and unnecessary. Here the obvious question is, were they eliminated on rational grounds, by letting them compete with science in an impartial and controlled way, or was their disappearance the result of military, political, economic etc., pressures? And the reply is almost always, the latter. The American Indians were not asked to present their views, they were first Christianized, then sold out of their land and finally herded into reservations amidst a growing scientific technological culture. Indian medicine, which was commonly used by medical practitioners of the 19th century, was not tested against the new pharmaceuticals that invaded the market, it was simply forbidden as belonging to an antediluvian age of healing. And so on. Reference to past opportunities also overlooks the point that 304. Even clear and unambiguous refutations do not seal the fate of an interesting point of view, for what follows, CFSFS, pages LO off, and Chapter 1, Section 1 of the present book, the means of refutation, experimental equipment, the theories used for the interpretation of the results obtained, constantly change, and with them the nature of the argument. One should also note the striking similarity between the argument from success and comments such as those made by the Nazis after their triumph in 1933, liberalism had already had its chance, it was defeated by the national forces and it would be silly to try to reintroduce it. Finally, it is up to the citizens to choose the traditions they prefer. Thus democracy, the fatal incompleteness of criticism, and the discovery that the prevalence of a view never is and never was the result of an exclusive application of rational principles, all suggest that attempts to revive old traditions and to introduce anti-scientific views are to be praised as the beginnings of a new age of enlightenment, where our actions are guided by insight and not merely by pious and often quite moronic slogans. 5. Reason and practice. What I have said so far can be summarized in the following two statements. A. The way in which scientific problems are attacked and solved depends on the circumstances in which they arise, the formal, experimental, ideological, means available at the time and the wishes of those dealing with them. There are no lasting boundary conditions of scientific research. B. The way in which problems of society and the interaction of cultures are attacked and solved also depends on the circumstances in which they arise, the means available at the time and the wishes of those dealing with them. There are no lasting boundary conditions of human action. Thus I criticized the view which I shall call, c. that science and humanity must conform to conditions that can be determined independently of personal wishes and cultural circumstances. And I objected to the assumption, d. that it is possible to solve problems from afar, without participating in the activities of the people concerned. C. and D. are the core of what one might call the intellectualistic approach to science and social problems. They are a matter of course for academic Marxists, liberals, social scientists, businessmen, politicians eager to help underdeveloped nations. 305. And prophets of new ages. Every writer who wants to improve knowledge and save humanity and who is dissatisfied with existing ideas, reductionism, for example, thinks that salvation can only come from a new theory and that all that is needed to develop such a theory are the right books and a few clever ideas. C. and D. have also been used to discredit what I say about politics. According to my critics, I make a lot of noise but achieve little. My approach, they say, is entirely negative. I object to certain procedures, but I have nothing to offer in their stead. Marxists have been especially incensed at my mocking disregard for their two favorite playthings, Western science and humanitarianism. These remarks are certainly correct. I have indeed no positive suggestions to make. But the reason is not that I have forgotten about the matter, or cannot compete with the speculative talents of my fellow academics. The reason is my respect for the traditions I am supposed to bless with my intellectual gifts. These traditions are historical traditions, not abstract traditions, see above, sections 2, 3 and 4, and chapter 3. Historical traditions cannot be understood from afar. Their assumptions, their possibilities, the, often unconscious, wishes of their bearers can be found only by immersion, i.e. one must live the life one wants to change. Neither, C, nor, D, apply to historical traditions. Boundary conditions and solutions invented by distant speculators can still be imposed, but only by disregarding the full humanity of the victims. Intellectuals who support the imposition are not unaware of the human dimension, they have theories of man and they use them as guides to their actions. But these theories do not reflect their victims, they reflect the mentality of the place where they arose, university offices and seminar rooms, mainly. Cf. my remarks on Tibor Maxim in section 4 above. My main objection against intellectual solutions of social problems is that they start from a narrow cultural background, ascribe universal validity to it and use power to impose it on others. Is it surprising that I want to have nothing to do with such ratio-fascistic dreams? Helping people does not mean kicking them around until they end up in somebody else's paradise. Helping people means trying to introduce change as a friend, as a person, that is, who can identify with their wisdom as well as with their follies and who is sufficiently mature to let the latter prevail. An abstract discussion of the lives of people I do not know and with whose situation I am not familiar is not only a waste of time, it is also inhumane and impertinent. It is a waste of time because the practical application of the 306 theories found will always have to be preceded by numerous changes which may wipe out the basic program. It is impertinent, being unfamiliar with the conditions of the strangers, with the ways in which these conditions appear to them, having no direct experience of their dreams, fears, desires. I refuse to make my own standards, my so-called knowledge, whether puny or impressive, that does not matter, my own very limited humanity the basis of objective diagnoses and suggestions. Only very naive or intolerant people can believe that a study of the nature of man is superior to personal contacts, in one's private lives as well as in politics. Yuta, who bears a woman's name but who seems bent on outdoing the chauvinism of the most pushy of her male academic colleagues, says that I am lacking in heart and imagination. On the contrary, can imagine that there are situations of which I have never thought, which are not described in books, which scientists have never encountered and would not recognize when confronted with. I believe that such situations occur quite frequently. I can also imagine that such situations look different to different people, affect them in different ways, raise hopes, fears, emotions I have never felt, and I have the heart to subject my distant guesses to the impressions of those immediately concerned. Yuta says I should examine with respect what I do not know. Examine. If I love a woman and want to share her life, for my benefit and perhaps also for hers, then I shall not examine that life, whether respectfully or with disdain. I shall try to participate in it, provided she lets me, so that I can understand it from within. Participating in her life, I change into a new person with new ideas, feelings, ways of seeing the world. Of course, I shall make lots of suggestions, I may even drive her nuts with all my talk, but only after the change has occurred and on the basis of the new and shared sensibilities it has created. Now politics, as I understand it, is in many ways related to love. It respects people, considers their personal wishes, does not study them whether by polls or by anthropological field work, but again tries to understand them from within, and connects suggestions for change with the thoughts and the emotions that flow from such an understanding. In a word, politics, rightly understood, is firmly subjective. It is impossible to develop objective theoretical schemes for it. 6 elements of a free society. How is this account related to my ideas about the police? The 307. Equality of traditions, the separation of state and science? The answer has already been given in SFS and EFM, P77 and PASM. Ideas such as these must pass the filter of the traditions, of the citizens' initiatives, for which they were developed. A fundamental error of almost all the papers that deal with this part of my writings, and that includes the paper by Christian van Briesen, who got my number in many other respects, is that they interpret my suggestions as if they should be read in the same way as politicians, philosophers, social critics, and great men and women of all sorts want to be read. They interpret them as the outlines of a new social order which must now be imposed on people with the help of education, moral blackmail, a nice little revolution and treacly slogans, such as "the truth will make you free," or by utilizing the pressures issuing from already existing institutions. But dreams of power such as these are not only very far from my mind, they positively make me sick. I have little love for the educator or moral reformer who treats his V-etched effusions as if they were a new sun brightening the lives of those living in darkness. I despise so-called teachers who try to whet the appetite of their pupils until, losing all self-respect and self-control, they wallow in truth like pigs in the mud. I have only contempt for all the fine plans to enslave people in the name of God or truth or justice or other abstractions, especially as their perpetrators are too cowardly to accept responsibility for these ideas but hide behind their alleged objectivity. Many of my readers seem to regard such machinations as a very normal procedure. How else can I explain that they read my proposals in this manner? But the loose and sketchy remarks on the state, on ethics, on education, and on the business of science which I made in AM and SFS must be examined by the people for whom they are meant. They are subjective opinions, not objective guidelines. They are to be tested by other subjects, not by objective criteria, and they receive political power only after everybody concerned has considered them. The consensus of those addressed, not my arguments, finally decides the matter. The objection that people must first be taught to think only reflects the conceit and the ignorance of its authors, for the basic problem is, who can talk and who should remain silent? Who has knowledge and who is merely obstinate? Can we trust our experts, our physicists, our philosophers, our healers, our educators? Do they know what they are talking about, or do they merely want to duplicate their own miserable existence? Have our great minds, have Plato, Luther, Rousseau, Marx, anything 308 to offer, or is the reverence we feel for them merely a reflection of our own immaturity? These questions concern all of us, and all of us must participate in their solution. The most stupid student and the most cunning peasant, the much-honored public servant and his long-suffering wife, academics and dog-catchers, murderers and saints, they all have the right to say, "Look here, I, too, am human, I, too, have ideas, dreams, feelings, desires, I, too, have been created in God's image, but you never paid attention to my world in your pretty tales. It was different in the Middle Ages." C.F. Friedrich here, Die Drittkraft, Frankfurt 1959. The relevance of abstract questions, the content of the answers given, the quality of life adumbrated in these answers, all these things can be decided only if everyone is permitted to participate in the debate and encouraged to give her or his views on the matter. The best and simplest outline of the ideas just explained is found in Protagoras's great speech, Plato, Protagoras, 320c 328d. The citizens of Athens do not need any instruction in their language, in the practice of justice, in the treatment of experts, warlords, architects, navigators. Having grown up in an open society where learning is direct and not mediated and disturbed by educators, they learned all these things from scratch. As for the further objection that states and citizens' initiatives do not arise out of the blue but must be set in motion by purposeful action, that is easy to answer. Let the objector start a citizen's initiative, and he will soon find what he needs, what furthers his ambitions, what obstructs them, to what extent his ideas are a help to others, to what extent they hinder them, and so on. This, then, is my answer to the various criticisms of my political model. The model is vague, very true, but the vagueness is necessary, for it is supposed to make room, EFM, p. 160, for the concrete decisions of those using it. The model recommends an equality of traditions. Any proposal must first be checked by the people for whom it is meant. Nobody can foresee the result. The Pygmies, for example, or the Mindoro of the Philippines, do not want equal rights, they just want to be left alone. Conflicts are not dealt with by education but by a police force. Margarita von Brentano interprets the last suggestion as implying that citizens may only talk and perhaps write but that their actions are severely restricted. Other critics have thrown up their hands in despair, speak of the police, and liberals and Marxists alike are liable to wet their pants. This is precisely the mistake described above. For the police is not an external agent. 309. That pushes the citizens around, it is introduced by citizens, consists of citizens and serves their needs. Cf. my comments on the protective guards of the Black Museums, EFM, p. 162, p. 297. Citizens do not just think, they decide about everything in their surroundings. I merely suggest that it is more humane to regulate behavior by external restrictions, such restrictions can be easily removed when found impractical, than to improve souls. For assume we succeed in implanting the good in everybody, how then shall we ever be able to return to evil? 7. Good and evil. With this remark I come to a point which has enraged many readers and disappointed many friends, my refusal to condemn even an extreme fascism and my suggestion that it should be allowed to survive. Now one thing should have been clear, fascism is not my cup of tea, cf. EFM, 156, despite my own very widely developed sentimentality and my almost instinctive tendency to act in a humanitarian manner. That is not the problem. The problem is the relevance of my attitude. Is it an inclination which I follow and welcome in others, or has it an objective core that would enable me to combat fascism not just because it does not please me, but because it is inherently evil? And my answer is, we have an inclination, nothing more. The inclination, like every other inclination, is surrounded by lots of hot air and entire philosophical systems have been built on it. Some of these systems speak of objective qualities and of objective duties to maintain them. But my question is not how we speak but what content can be given to our verbiage. And all I can find when trying to identify some content are different systems asserting different sets of values with nothing but our inclination to decide between them. SFS, Part 1. Now if inclination opposes inclination, then in the end the stronger inclination wins, which means, today, and in the West, the bigger banks, the fatter books, the more determined educators, the bigger guns. Right now, and again in the West, bigness seems to favor a scientifically distorted and belligerent, nuclear weapons, humanitarianism, and so the matter has come to a temporary rest at this point. This, incidentally, was one of the lessons I learned from the life of Remigius, the Inquisitor. Margarita von Brentano, who mentions my reference to him, was kind enough not to assume. 310. That I am pleading for a revival of witchcraft and witchcraft persecutions. Of course, this is not my intention. Nor do I think I would remain a silent witness of such persecutions. But my explanation would be that the matter does not please me and not that it is inherently evil or based on a backward view of the universe. Such expressions far exceed what can be supported by the best intentions and the most clever arguments. They give the user an authority he simply does not possess. They put him on the side of the angels when all he does is to express his personal opinions. Truth herself seems to be his companion when again we are dealing only with an opinion and a very badly argued one at that. There existed lots of arguments against atoms, the motion of the earth, the ether, and yet all these things return to the scene. The existence of God, the devil, heaven, hell was never attacked with even halfway decent reasons. Thus if I want to remove Remigius and the spirit of his times, then I can of course proceed to do so, but I must admit that the only instruments available to me are the powers of rhetoric and self-righteousness. If, on the other hand, I accept only objective reasons, then the situation forces me to be tolerant, for there are no such reasons, in this case any more than in others. SFS, Parts 1 and 2, EFM, Chapter 3. Remigius believed in God, he believed in an afterlife, in hell and its tortures, and he also believed that the children of witches who were not burned would end up in hell. He did not just believe those things, he could have provided arguments. He would not have argued in our manner, and his evidence, the Bible, the Church Fathers, the decisions of church councils, etc., would not have been what we call evidence. But this does not mean that his ideas were without substance. For what do we have to oppose him? the belief that there is a scientific method and that science is successful? The first part of the belief is false, cf. section 2 above. The second part is correct but must be supplemented by saying that there were and still are many failures as well, and that the successes occur in a narrow domain that hardly touches what is at issue here. The soul, for example, never enters the scene. What falls outside the domain, such as the idea of hell, was never examined, it was lost, just as the scientific achievements of antiquity were lost by the early Christians. Within the framework of his thought, Remigius acted as a responsible and rational human being, and he should be praised, at least by rationalists. If we are repelled by his views and unable to give him his due, then we must realize that there are absolutely 311. No objective arguments to support our repulsion. We can of course sing moral arias, we may even write an entire opera where these arias hang together beautifully, but we cannot build a bridge from all that noise to Remigius and, appealing to his reason, bring him over to our side. For he does use his reason, but with a different purpose, according to different rules and on the basis of different evidence. There is no way out, we bear full responsibility for not proceeding as Remigius does, and no objective values will plead our case should we discover that our actions have led to disaster. On the other hand, let us not forget our own inquisitors, our scientists, physicians, educators, sociologists, politicians, developers. Just look at those physicians who until quite recently cut, poisoned, and irradiated without having examined alternative methods of treatment which were well known, had no dangerous consequences, and could claim to be successful. Was it not worth trying such methods? Was it not worth trying to keep the children of witches alive? It was worth trying. But all we heard in reply was, anathema sit / or let us examine the efforts of our educators who year in year out are let loose on the younger generation to fill it with knowledge without regard for the background of the pupils. Entire cultures have been killed, their immune systems destroyed, cf. section 4, their knowledge turned into a scarcity, and all that in the name of progress, and money. Of course the spirit of Remigius, my dear Margarita von Brentano, is still with us, in economics, in energy production and, use, in foreign aid, in education, the important difference being that Remigius acted for humanitarian reasons, he wanted to save little children from eternal damnation, while his modem successors only care for their professional integrity. They not only lack perspective, they also lack humanity. I don't like them, either, but here my motives are again not objective standards, but dreams of a better life. Now if one combines such dreams, which I have, with an idea of objective values, which I reject, and calls the result a moral conscience, then I have no moral conscience, and fortunately so, I would say, for most of the misery in our world, wars, destruction of minds and bodies, endless butcheries are caused not by evil individuals but by people who have objectivized their personal wishes and inclinations and thus have made them inhuman. This, incidentally, is the only thing Agassiz seems to have noticed in his strange outburst. Agassiz says he will speak the truth. That 312 is nice of him but does not give us much comfort. For as critics of his scientific work have pointed out, long ago, he only rarely knows what he is talking about even when he is trying to tell the truth. For example, item 882 in Rosen's Copernicus bibliography. 3 Kopmichan Treatises, New York 1971. His paper confirms the impression. He says I volunteered for the German army, I was drafted. He says I tried to forget the political and moral aspects of the Second World War, one did not notice them, at 18 one was a bookworm not a mensch. He says I idolized Popper. Now it is quite true that I like to idolize people, I like to be able to look up to somebody, to admire her, to take her as an example, but Popper is not the stuff idols are made of. Agassiz calls me a disciple of Popper. This is true in one sense, quite untrue in another. It is true that I listened to Popper's lectures, sat in his seminar, occasionally visited him and talked to his cat. This I did not of my own free will but because Popper was my supervisor. Working with him was a condition of my being paid by the British Council. I had not chosen Popper for this job, I had chosen Wittgenstein and Wittgenstein had accepted. But Wittgenstein died and Popper was the next candidate on my list. Also, doesn't Agassiz remember how often he begged me, on his knees, to give up my reservatio mentalis, fully to commit myself to Popper's philosophy and, especially, to spread lots of Popper footnotes all over my essays? I did the latter. Well, I am a nice guy and quite willing to help those who seem to live only when they see their name in print, but not the first. At the end of the year Agassiz is speaking of, 1953, Popper asked me to become his assistant. I said no despite the fact that I had no money and had to be fed now by the one, now by the other of my more pecunious friends. Agassiz also produces some of the rumors which are apparently needed to make life in the Popperian church bearable. He quotes Popper as saying that I once tearfully regretted having participated in the Second World War. That is quite possible. I am an emotional person and have done many stupid things in my life, but it is unlikely. I never discuss personal matters with strangers and, besides, there was nothing to be sorry about except perhaps insufficient intelligence in the attempt to escape the draft. The tears, most likely, were tears of boredom which flowed rather freely during my visits to the master. It is a sad sign of the decay of standards of scholarship in Germany that a piece of lachrymose trash like Agassiz's essay could be written with the 313 8 of a stipend that bears the old and honorable name of Alexander von Humboldt. There is only one point where Agassiz shows some grasp of reality, and this concerns our discussion of moral issues. I remember the discussion well. Agassiz urged me to take a stand, i.e. to sing moral arias. I felt very uncomfortable. On the one hand the matter seemed quite idiotic. I sing my aria, the Nazi sings his, now what? On the other hand I felt the irrational pressure of Auschwitz which Agassiz and many ideological street singers before and after him have used shamelessly to urge people into empty gestures, or to brainwash them so that the gestures receive meaning. What do I say today? I say that Auschwitz is an extreme manifestation of an attitude that still thrives in our midst. It shows itself in the treatment of minorities in industrial democracies, in education to a humanitarian point of view included, which most of the time consists in turning wonderful young people into colorless and self-righteous copies of their teachers. It becomes manifest in the nuclear threat, the constant increase in the number and power of deadly weapons and the readiness of some so-called patriots to start a war compared with which the Holocaust will shrink into insignificance. It shows itself in the killing of nature and of primitive cultures with never a thought spent on those thus deprived of meaning for their lives, in the colossal conceit of our intellectuals, their belief that they know precisely what humanity needs and their relentless efforts to recreate people in their own, sorry image, in the infantile megalomania of some of our physicians who blackmail their patients with fear, mutilate them and then persecute them with large bills, in the lack of feeling of many so-called searchers for truth who systematically torture animals, study their discomfort and receive prizes for their cruelty. As far as I am concerned there exists no difference whatsoever between the henchmen of Auschwitz and these benefactors of mankind. Life is misused for special purposes in both cases. The problem is the growing disregard for spiritual values and their replacement by a crude but scientific materialism, occasionally even called humanism. Man, i.e. humans as trained by their experts, can solve all problems. They do not need any trust in and any assistance from other agencies. How can I take a person seriously who bemoans distant crimes but praises the criminals in his own neighborhood? And how can I decide a case from afar? 314. Seeing that reality is richer than even the most wonderful imagination. It is one thing to be in the forefront of the fight against cruelty and oppression, for then you can see and smell your enemy, and your whole being, not only your ability to rhapsodize, will be engaged in the attempt to defeat him. It is quite a different thing to shake one's head and to decide about good and evil while sitting in a comfortable office. I know, many of my friends can make such a decision with both hands tied behind their back, they obviously have a well-developed moral conscience. I, on the other hand, taking the distance seriously, would like to consider a different view where evil is part of life just as it was part of creation. One does not welcome it, but one is not content with infantile reactions either. One delimits it, but one lets it persist in its domain. For nobody can say how much good it still contains and to what extent the existence of even the most insignificant good thing is tied up with the most atrocious crimes. 8. Farewell to reason. What was the origin of the criticisms on which I have commented in this chapter? And why did I write a reply? It is easy to answer the first question. About 8 years ago, 1979, Hans-Peter Duer was invited to become an author of the famous Suhrkamp publishing house in Germany. He refused, for he had other obligations. But he also had a bad conscience. It is not easy for Hans-Peter to reject friendly invitations. Dr. Unselt, the guiding spirit of the Suhrkamp publishing house whose ability to sniff out the bad conscience of people is only exceeded by his expertise in manipulating it, discovered Hans-Peter's predicament and treated it with words, food, and drink. Result, Hans-Peter conceived the idea of a PKF festival and started sending letters in all directions. Some of the letters were returned unopened, others with reflections on his sanity, still others with the customary excuse of lack of time, but quite a few people decided to praise me or to curse me, or to exorcise me by surrounding me with rhetorical circles. Thus it was not the merit of my work that led to this collection, but the power of alcohol. It is much more difficult to answer the second question. Many people, scientists, artists, lawyers, politicians, priests draw 315. No distinction between their profession and their lives. If they are successful, then they take this as an affirmation of their very existence. If they fail in their profession, then they think they have failed as human beings as well, no matter how much joy they may have given to their friends, children, wives, lovers, dogs. If they write books, be they novels, collections of poems, or philosophical treatises, then these books become part of an edifice built from their very substance. Who am I? Schopenhauer asked himself, and he replied, I am the person who wrote the world as will and idea and solved the great problem of being. Parents, brothers, sisters, husbands, mistresses, parakeets, budgerigars for my British readers, even the most personal feelings of the author, his dreams, fears, expectations, have meaning only with respect to that edifice and they are described accordingly. The wife, well, she knew how to cook, to clean, to wash, and to create the right atmosphere. The friends, well, they understood the poor chap during trying times and gave him support, they lent him money, they eagerly helped with the birth of the monsters he brought forth, and so on and so forth. This attitude is widespread. It is the basis of almost all biographies and autobiographies. It is found in really great thinkers. Socrates, a few hours before his death, gets rid of his wife and children so that he can chat about profound things with his adoring students, Phaedo 67. The artistic parallel is told with gusto and much hatred by Claire Go in her autobiography, Ich verzeih keinem, Munich 1980, but it is also quite common among the academic rodents of today. To me this attitude is alien, incomprehensible, and slightly sinister. True, I, too, once admired the phenomenon from afar. I hoped to enter the castles from whence it spread and to participate in the wars of enlightenment the learned knights had started all over the world. Eventually I noticed the more pedestrian aspects of the matter, the fact, that is, that the knights, the professors, serve masters who pay them and tell Tom what to do. They are not free minds in search of harmony and happiness for all, they are civil servants, denkbeamt, to use a marvelous German word, and their mania for order is not the result of a balanced inquiry, or of a closeness to humanity, it is a professional disease. So while I made full use of the sizable salaries I got for doing very little, I was careful to protect the poor humans, and, in Berkeley, dogs, cats, raccoons, even a monkey now and then, who came to my lectures from the disease. After all, I said to myself, I have some kind of responsibility for these people and 316. I must not misuse their trust. I told them stories and I tried to strengthen their natural contrariness, for this, I thought, would be the best defense against the ideological street singers they were about to meet. The best education consists in immunizing people against systematic attempts at education. But even these friendly considerations never established a closer bond between me and my job. Frequently, when driving by the university, be it now in Berkeley, or in London, or in Berlin, or here in Zurich where I am paid in solid Swiss francs, I was startled at the thought that I was one of them. I am a professor, I said to myself. Impossible, how did it happen? Concerning my so-called ideas, my attitude was exactly the same. I always liked to debate with friends, about religion, the arts, politics, sex, murder, the theater, the quantum theory of measurement and many other topics. In such discussions I took now one, now another position, I changed positions and even the shape of my life, partly to escape boredom, partly because I am counter-suggestive, as Karl Popper once sadly remarked, and partly because of my growing conviction that even the most stupid and inhumane point of view has merit and deserves a good defense. Almost all my written, well, let us call it work, starting with my thesis, arose from such live discussions and shows the impact of the participants. Occasionally I believed I had thoughts of my own, who does not now and then become a victim of such delusions? But I would have never dreamt of regarding these thoughts as an essential part of myself. So I said when considering this matter, am very different indeed from the most sublime invention I have produced and the most deeply felt conviction that pervades me, and I must never permit these inventions and convictions to get the upper hand and to turn me into their obedient servant. I might even take a stand, though the practice and even the phrase with its puritanical connotations put me off, but when I did so, then the reason was a passing whim, not a moral conscience or any other nonsense of that kind. There was another element hidden behind my unwillingness to take a stand, and I have discovered it only recently. I wrote partly to tease Lakatos, who was supposed to write a reply but died before he could do so, and partly to defend scientific practice from the rule of philosophical law. Having absorbed Ernst Mach when about 15 and having been a student of Hans Thüring and Felix Ehrenhoft in physics, I took it for granted that the work of scientists was self-supporting and did not need any 317 outside legitimation. I got impatient with people who, though lacking any experience of the complexity of scientific research, still claimed to know what it was all about and how it could be improved. I guess I was a kind of a scientific libertarian, and my battle cry could have been "Leave science to the scientists." Of course, I had once been a rationalist myself, but it needed only a simple practical example, it needed only Prof. von Weizsäcker's concrete arguments, in Hamburg, back in 1965, I believe, to reveal the shallowness of rationalistic orations and to make me return to Mach. There was a second experience that had a tremendous influence upon me. I repeat it in the words in which I first described it, SFS, 118F. In the years 1964 FF Mexicans, blacks, Indians entered the university as a result of new educational policies. There they sat, partly curious, partly disdainful, partly simply confused, hoping to get an education. What an opportunity for a prophet in search of a following! What an opportunity, my rationalist friends told me, to contribute to the spreading of reason and the improvement of mankind. What a marvelous opportunity for a new wave of enlightenment! I felt very differently. For it dawned on me that the intricate arguments and the wonderful stories I had so far told to my more or less sophisticated audience might be just dreams, reflections of the conceit of a small group who had succeeded in enslaving everyone else with their ideas. Who was I to tell these people what and how to think? I did not know their problems, though I knew they had many. I was not familiar with their interests, their feelings, their fears, though I knew they were eager to learn. were the arid sophistications which philosophers had managed to accumulate over the ages and which liberals had surrounded with schmaltzy phrases to make them palatable, the right thing to offer to people who had been robbed of their land, their culture, their dignity, and who were now supposed to absorb patiently and then to repeat the anemic ideas of the mouthpieces of the oh-so-human captors? They wanted to know, they wanted to learn, they wanted to understand the strange world around them. Did they not deserve better nourishment? Their ancestors had developed cultures of their own, colorful languages, harmonious views of the relation between man and nature, whose remnants are a living criticism of the tendencies of separation, analysis, self-centeredness inherent in Western thought. These were the ideas that went through my head as I looked at my audience, and they made me recoil in revulsion and terror from the task I was supposed to perform. For the task, this now became clear to me, was that of a very refined, very sophisticated slave driver. And a slave driver I did not want to be. 318. This experience was similar in nature to my experience vis-a-vis physics. There, too, I had strongly felt the superficiality and presumptions of a philosophy that wanted to interfere with a well-formed practice. However, while science is only part of culture and needs other ingredients to arrive at a full life, the traditions of my audience had been complete from the very beginning. Thus the interference was much more serious and much stronger resistance was needed. Trying to build up such resistance I considered intellectual solutions, that is, I still took it for granted that it was up to me and the likes of me to devise policies for other people. Of course, I intended to devise much better policies than those imposed by President Johnson and his aides, but in doing so I, like he, took responsibility away from those I wanted to help. I dealt with them as if they were not capable of taking care of themselves. It seems that I was aware of this contradiction, and it was this unconscious awareness that made me act in a distant and unconcerned way and made me refuse to take a stand. Now comes the third experience on my path, my acquaintance with Grazia Borini, a gentle but determined fighter for peace and self-reliance. Grazia had studied physics, as I had. Like me, she had found this study too confining. But while I was still using abstractions, such as the idea of a free society, to arrive at a wider and more humane point of view, her ideas were part of historical traditions, to relapse into my own constipated manner of speaking. I did know about these traditions and I had written about them even before I met Grazia, but again it needed a concrete encounter to make me realize what that implied. Grazia also gave me books and papers written by outstanding scholars dealing with the problems of economic and cultural exchange. This was a real find. First, I now had much better examples of the limits of a scientific approach than those I had been in the habit of using: astrology, voodoo, a little bit of medicine. Secondly, I realized that my efforts had not been in vain and that it needed only a SHGHT change in attitude to make them effective, both in my own eyes, and in the eyes of others. You can help people by writing books. I was very surprised and deeply moved when I noticed that people from different cultures whose actions I respected had read some of the things I had written and had welcomed them. So, I finally gave up my self-cynicism and decided to write one last, but good book, for Grazia, because I know her and because I write best when I have a smiling face before me. Remember, I wrote AM with Imre Lakatos in mind, and, through her, for all the people who. 319. Despite hunger, oppression, wars, try to survive and to achieve a little bit of dignity and happiness. Of course, to write such a book I shall have to cut the remaining strings that still tie me to the abstract approach, or, to revert to my usual irresponsible way of talking, I shall have to say